It looks like everybody's comfortable, so I would like to welcome you here in Ostrava at Python Pizza conference this year. I'm really glad that we met in such a huge amount. The conference is actually sold out. So I'm really glad for it. And we also arrived from various places. So as a morning exercise, could you please raise your hand if you are from Ostrava? Okay, could you please raise your hand if you are from Czech Republic, but not Ostrava? Okay, thank you very much for coming here by trains and having the long ways. And is there anyone from abroad? Wow, so we can actually consider this an international conference. Okay. Okay, so there's a huge thank to people who organized this conference, as we couldn't be here without them. I'd like to introduce them because they will be here for all the day. You can ask them questions, and you can also go and check tickets if you didn't do it yet. We need it for statistic purposes, so it will help us a lot. There is Lumir, Aneška. There is Moises. Also, Carolina Surma helped. Mia is missing. Not sure whether she will come, but she also has a credit for all the visual stuff. And so, thanks a lot to Piotr, who is doing a stream. We also couldn't be here without our sponsors. It's actually, I always thought that the sponsor part is quite a boring part until I went into conference organizing. It's actually very comfortable to feel financially secured and be able to buy all the food and book this nice room. So many thanks to Red Hat, Barclays, EuroPython Society, Pivettes, and I would also like to thank a lot to Impact Hub because collaboration with their employees was very smooth and they were very helpful in any kind of way. Okay, so what you can expect here now is catering that is prepared in the room upstairs. Yeah, you need to take the upstairs here, then walk that way. And it will be ready for the first coffee break. During all the conference, you also have access to water and to coffee and tea. Feel free to take it anytime you would like to refresh. For lunch, we will have a pizza. There are also versions for vegans. If you are not vegans, please take the food which is not vegan, so they are able to have their food. Okay. So if you didn't connect to Wi-Fi yet and you would like to, the password is I feel good with big letters at the beginning of words like big I, big F, big G, yeah, it looks like I said everything I wanted. So good luck to speakers, enjoy the conference, and have a nice day.
Actually, one more organizer to thank, Martina. And with that, I think we can start. So, let's make it fast today. The first speaker of the day is Ada, telling us about Nelzi.
My time is running. Okay. So, welcome. I'm Ada. I normally work on Supercomputing Center, and I create schedulers for supercomputers. But from time to time, I am a public speaker, and I speak on some occasions. And I want to talk about slides and why to make sense to make slides in a Python, and how it's important to really like to mitigate where people are focusing. It's quite important, because if you have slide like this, I just want to convey some emotion. I want to convey, like, you can trust me, I speak publicly a lot, and I know things. But if I want to convey some knowledge, not only feeling, that you really have to control where people are looking. Otherwise, you are depleting their mental energy on trying to decipher the slide. Let's have an example. This is just, there are some random slides from the internet, the wobble block sphere, which is something in quantum computing, which I assume that you don't know what it's about. But if you have never seen what is the block sphere, if I just want to convey the idea, okay, it's something really complex, then the slide is okay. But if I want to really explain it to you, like, you don't know where you should look, like, should I look here, or discover these arrows, or whatever. So this is bad slide for explaining. You have to control where people are actually looking. And this is not a new idea. If you are working with the blackboard, like, even if you do not know what is this guy talking about, what is the lecture about, you know that you should be looking here, and you don't have to care about this picture. So if you are if you are just slowly drawing or the presentation like a story, that it makes sense, you can also much easier convey the knowledge. And I'm not, my message is not go back to the blackboards. It has lots of disadvantages. But, like, think about to make a slides in this way, and this is the reason why I've created Nelsie, the tool that is focused particularly on this, because the tools like the PowerPoint, it just helps you put there lots of stuff at once, and just one click and lots of things will be shown at once. So how it looks like, it's a Python package. You will just import the slide deck, instantiate the slide deck, put there a slide, put there a text into the slide, render in the PDF, and you will get the PDF with just one slide that looks like this. And I said I want to control about when and what is shown. And most easiest way, you can have an editor, whatever one. Usually there is some layers, and in these layers, you can name the layers. And if you name it in the right way, this means the cog is always shown, the letter N is shown from the second slide, the ferry is shown from the third slide. If you if you save it in the format that preserves layers, like SVG or open raster format, this Aura format. So now I put the image into the slide, and what I will get the presentation with 3 slides. First, just there is a cog, there is an N, there is a ferry. And I can also do it in the code. Like, I have here I have an example where there is a box that is just the gray box, gray rectangle. Then I will put a red square inside. If I will render it, it will be this. Now I want to create something like the traffic lights, like red, orange, and green. How I can do it? In PowerPoint, I have to copy-paste it. So I will have lots of copy-pasted slides, and if I want to change something, that I have to edit, like, lots of slides. How I can do it in the Nelsie? So here, the red is the constant. I can wrap this constant in the step value, and this will not change anything. If I will render the slides, it will still you will see the same thing. But then I can say, okay, at the step 2, show it in the orange. At the step 3, show it in the green. In the y-axis, I can do the same. This is the constant. I will wrap it in the step value. Now I will say, okay, at the step 2, make a different y-axis. At the step 3, have a different y-axis. If I will render it, I will have 1, 2, 3. So I didn't copy-paste the slides. I have still the same slides. I just defined the frame keyframes. Only what changed. I changed the colors and changed the Y position. All other things are the same. So if I now want to change this gray part to something else, I will just edit in one place. I will not edit like billions of the slides. So this does not discourage me from creating like precise animation what I want to show. Of course, there are I use Python. Why I think that it's important to use like full-featured language. If you are not a programmer and you don't know how to code, just to learn programming because of the slides, it doesn't make sense. But if you are a programmer, you know how to code, why not to utilize this knowledge under the discipline? Like, you are not forgetting it. And of course, we can use some DSLs, but usually you don't have just precise control. The markdown is quite popular, but some people say something like, okay, but it gives you some separation of the meaning and the styles, and you can style your slide. but it's a good concept for the documents, it's a good concept for the web pages, but it doesn't make sense in the slides, or it's not harmful, but it's not useful, because slide is a visual artifact, and if you have a visual artifact and you change the style, you are changing the message. So I have a visual artifact, and I will change the style, I'm sending a different message. So if you do not think about how your slide looks like, and what people will see, and you just say, okay, I will decide later because of the style, you are probably creating wrong slides. Also, let's assume that I want to create this kind of slide. I want to explain something technical on some grids, so let's say, and just to create something like this in PowerPoint, there will be lots of clicks and lots of editing text. But we are in Python, we have 4 cycles. So I will just create like 4 cycles, and it is. If I want to create some animation, okay, again, I can, for example, let's assume I want to do something like this. This is, like in PowerPoint, I would have to do lots of copy-paste. If I decide later, okay, the green is not a good color, then I will have to redo lots of slides. It will be very tedious. Here, I have a Python, I have 4 cycles, if conditions, so I can just express all this thing in one thing. If I want to change anything, it's still on the one page of the code. And I can create the functions if I repeat lots of time and things like this. The backend is written in Rust, so it has a full Python interface, but the backend is written in Rust, so it's very fast, and I create custom PDF renderer, so you can like render hundreds of slides under 1 second without any caching or anything like this. And I have 3 minutes. I was so afraid that the presentation will be too long, so I am speaking much faster than I expected. So just some final message, like use any tool you want for creating slides. It doesn't matter. But like if you really need to have a slide, if you do not need slides, do not create the slides. Bad slides is much worse than no slides at all. But if you want to create a slide, like think about where people are actually looking. If you do not know, as your author, where the people should be looking, how the people should know it. So really think about it like I am working with the audience focus. So if I know exactly, okay, the people should look like that, and then it helps a lot to your presentation. If you just show lots of things at once, and then the people will just scatter their focus on different parts, you just lost lots of time and lots of mental power of the audience. So this is end of my presentation.
Thank you, Adam. So in this format, we don't have any questions. So once you're done with the talk, you get the applause, hopefully. And then it's time for the next speaker. Who is that? All right, so while Karolina sets up, I'm here to fill the time, right? Yes, please. Special request. 2 minutes, yeah. So the time to change presentation is 2 minutes. If the previous speaker was faster, then you get a bit more time for another lightning talk. And who has been at a Python pizza before? Has. So the people there have been at pizzas, and the people there are either not paying attention, which is perfectly fine for me. Yes. Oh, no slides. Ah, clever. No slides, no setup, more time for you. Are you ready? This one, all right. So this is Karolina saying something about scratching itches.
Hi there. I don't have a presentation, as you noticed, so you can kick back, relax, close your eyes, take a deep breath in, take a deep breath out, and think of one thing you are grateful for this morning. There is a set of problems in the world which I see around me, and there's a set of problems that technologies try to solve. Sometimes they try to solve people problems. And I've got this personal beef with how technologies approach solving the people issues. Not only sometimes they don't solve the issue, but they seem to deepen it. Just think about the feelings of loneliness and alienation in the era of social media and dating apps. But those are like big companies, and I still believe that we can use tech to aid, to help us, to help people problems. As individuals, as an individual, I can just scratch my itch. I can solve my problems. I can use the technology to actually focus on the issue at hand, rather than figure out the return of investment and the cash flow. So, human brains are really amazing. Research says that whenever you feel grateful for something, the feeling of fear and anxiety cannot coexist. That's why there's this exercise in mindfulness you may have heard about, to jot down 3 things you're grateful for every day. And as our brains are kind of directed towards negativity feelings, we are very good at picking what's wrong everywhere. We've got to combat it with a lot of positive inputs to somehow balance it out. When thinking about that, those 3 things that I'm grateful for every day, I start thinking that I might want to assemble a word cloud that would just create this fog of joyful sparks in my life in time. Or I would like to see some flashbacks, like what I was grateful for 3 months ago or a year ago. And now I just described to you a specification of an app I would like to have in my phone. And in fact, I do have an app like that. I'm not a Java Android developer. I always wanted to get to that. I wanted to learn that, but there's just no time, no space for it. This is where LLMs come into scene. Like, they are widely available, still relatively cheap. They are trained on code. They are perfect for applications that are new but not novel. Oh, one more thing. You can download an app like that from any kind of app store. It's just, I don't trust where the data is stored. I don't want to put my mental health into 300 of advertisement companies. So one of the things I was focusing on when specifying the app was that it's local. It stores the data on the device. It doesn't talk to a mothership. It doesn't ping anything, ever. It's a little bit like if you remember internet and technologies in 2005. You know, you just download the program and installed it, and that was it. It worked forever, offline. So my trust issue led me to experiments with LLMs, and I think that this is actually one of the really good usages you can have. Moving on. Who's interested in my period data? Yeah. I think we all feel that it's kind of private, and it's not anybody's business in this room but me. It's the same thing. I can download an app. This is actually very valuable data. It's important for me. It's important for my doctor. It could be also a matter of some political things. I don't want to go into that. It's just dystopic futures. I've got all the reasons to store those private data in a matter that I believe I trust. And again, I have employed LLM to build an app for that in the way that it suits me. I was able to adjust the preference. When you build a product for one person, not for 1 million, you can make it exactly as you want to. So think about your preference. I prefer text interfaces to images or icons or symbols. I have a very small hand, like my phone. Wow. I use left hand. And let me tell you, nobody designs apps or any other tools for that matter for hands like that. So I'm free to solve my issue in a way that I don't have to care about anything else. Like I can do this thing exactly as I want it. So the adjustment of the preference is a really big thing. I would like to encourage you to also think about things you can do. One of my apps is written in Flutter. I skimmed over the code to check that it really doesn't communicate with anything I don't want or mine by bitcoins. The other app is written in Python using Beware framework. I'm not showing you the code is horrible, but who cares? The classes are tightly coupled. There are no tests, but it works. I compiled it, I loaded it through cable to my phone, and I use it ever since. I will never try to monetize it. I don't distribute it. I don't have to care about licenses. I have no idea what kind of code the LLM was trained on. And if I wanted to distribute the app, I would probably have to dig much deeper into that. But I don't have to. Like, you know, this espionage device I bring everywhere with me is a little bit more of a brick at the moment of the brick I would like it to be. So this whole thing, it makes me feel more in control of, like, which I feel I've lost in the last years. And it's a good feeling, and that's what matters. Thank you.
Thank you, Karolina. Again, if you have any questions, Karolina is probably staying around. And let's see, do we have a next speaker lined up? Somebody's coming, and I see a laptop, so there will be some kind of setup involved, which means I can continue with my hand-raising things, right? So who of you has been to a Python conference before? Not everyone. Nice. So if you've been to a Python conference, you probably know the lightning talks. At the end of days, it's usually at the end of a day, 10-minute or 5-minute talks, which tend to be one of the best things about the conference, because people can just come and talk about a fun thing they made or make you think about something. And if you don't like the talk, then you just wait 5 or 10 minutes and it's over and somebody else comes along. And I've always loved that concept. So when I saw the concept of a whole day of lightning talks, that's I was pretty excited, and here we are. And I think we're ready, so I'll continue in 10 minutes. All right, here is Martin telling us about something in French. You pronounce it, okay?
Yeah, no problem. Oh, okay, we can see it. Okay, so hello, my name is Martin, and sometimes I'm programming stuff, not always. But. So today I want to tell you about this project or Python package, which is called Fromage. I hope I pronounce it correctly. The project builds wheels, Python wheels. So as you can see, there is a wheel of cheese. So that's why Fromage. So why this exists? I think the name of the presentation was Fromage, how to build your own Python index. So this is something that we actually do at my work, where I work, and we build custom indexes for our customers that they can use for different kinds of payloads or projects or so. So And this project and this Python package is very crucial to this, because basically you can provide him any combination of Python wheels, and it will try to build them in a way that they will be compatible together. So first thing what Fromagere enables us is to custom rebuilds of groups of Python packages. So it means that you will just put something together that you need, and then Fromagere will tell you if it's possible to build it or not. And you can then, tweak it, change versions, and so on to build what you want. Another point why we are doing is that with Fromagere we have all the evidence about the source code that comes into your build. So it means you have all the source codes about your Python packages, you have all the source codes of your binary packages or additional drivers that you need to be built there, because basically if there is no source codes, Fromagere will not be able to build it, of course. So that's that. Yeah. So one thing what we use this also for is that we sometimes there is a requirement from our customers or from the company that we provide something from upstream, but we don't want the actual version, the latest version from upstream. So, for example, you have an older version that you support in your company. But you, for example, want also the latest CV fixes and additional patches that you want to have in your build, but you don't want all of them, so you have to cherry pick them. And this is another thing that Fromagere can help you with the different packages. And the last thing which we use Fromagere a lot is that we build different versions of one package. So, and when I say versions, I don't mean like version, like the version number, but the different variant of a package. So, for example, you can have a package which needs different hardware to work. But this hardware, the drivers for the hardware are, for example, C code or something like that, which you can have to build together with this package. But for example, you need this on different kinds of hardware, so you have to build the drivers differently each time. So that's basically you build a different variant of the same wheel. Yeah. By the way, anyone from my team here? Hey, František is there. Great. Okay, so the basic usage of Fromagere. Fromagere is an open source tool, by the way, and you can find it on GitHub. I have links in the presentation at the end. So basically, what you need to start using Fromagere is just the requirements file. Nothing else is needed. You will just, write Fromagere bootstrap and provide the requirements file. What it will do then, it will look at the packages that you have there, and the first step of this is that it will try to figure out the dependency resolution. So basically, it will look at your file and will say, is this something that is possible to run, or is it something that is possible that I can basically build? Are there any version conflicts and so on? So that's the first thing. Of course, as I said, you can customize your build of your index, and this is basically you can add a constraints txt file where you will specify which specific versions you want to build for your Fromagere for your index. Of course, if you will put the version pins in the requirements file, that also works, but basically we want to have always constraints in the other file. So that's that. Yeah, so yeah, you can say like, okay, so now, yeah, so you said that we can build according to requirements and constraints, but this is something that already there are tools for it that can do it. So why should we use Fromagere? So Fromagere has additional features that can help you to customize your build even further. One of those features is that you can customize your build root settings. So basically, you will provide a settings file for for packages that you want actually to modify in some way, and you can set up their all the things. You can define environment variables in your build root. You can define which PyPI index you should use for getting the SDist to build it, and so on. So there is multiple versions. So this is like a small example of such a settings file, which is for for the Python package Torch, which is AI stuff. As you can see, there is a lot of stuff here defined from where we are getting the sources, what environment variables needs to be set. And then in the end, you can see that there are variants, different variants. So we built, for example, Torch for CPU, which doesn't need an accelerator. Then you build it for a Gaudi accelerator. Then you can build it for CUDA, and so on and so on. So there you can always define specific things that you want to build for different kinds of variants. This is one thing, which is customizing the build root. And the second thing is you can also apply upstream patches or any patches you want to your build for each package. The only thing that you need is basically, again, specify a patches directory, which will look something like this. Fromager uses the standard diff as a patch, as you would, for example, send a patch to kernel through a file. So this is the same thing. As you can see, you can specify specifically for any package, for the name or the version, specific patches, which then you can get like different variants again of your packages. So that's that. There are several other options in Fromager, and Fromager is quite complicated. Fromager creates also few interesting things that you can reuse or archive for a reference. For example, when you do a build through Fromager, it will create a graph.json file where it will basically create you a graph of the dependencies, how they should be installed, or what is the dependency graph. So that's also like an interesting thing that you can basically store if you want to have like a SBOM or something, what went into your package when you build it. So that's quite useful. Also, I think Fromager creates like a build order file where it shows you like which packages needs to be installed in what way, so everything can be built. So what has to be installed in your build root to get it done. Yeah, as I said, presentation, there are 3 links to you to look at. Is just the documentation, of course, the GitHub of Fromager, and then there is one repository that my teammate made, Lala, and it's for learning Fromager. It's for our team, but it's also open source. You can look at it. There are like examples how you can use how you can use Fromager. How can you build like simple wheels. And I think that's all. Thank you.
Thank you, Martin. You're doing great on time. Yeah.
I prepared.
Yeah, so our next speaker is coming up. Take your time setting up. We are a bit ahead. Which is good, right? Who wants a longer coffee break? The people who are paying attention, right? All right. So next up will be Christian telling us about home automation and not making it too smart with Python, hopefully, right? All right. Are you ready?
Yes, I think I am. Oh, yeah. We're already seeing the slides.
This is Christian.
Perfect. Okay, yes. Thank you very much for the introduction. So I feel really honored to speak here today. It's actually already my 2nd time that I'm speaking in this format. So it was exciting last time, and I'm pretty sure that it will also get exciting this time. So the title of my talk is Not So Smart Power Plugs, but at least no cloud is required. So what is it all about? Well, some time ago I asked myself the question, I want to track the energy use of some devices in my apartment, like at the desk, at the TV, at the kitchen, stuff like that. And in principle, there are all these nice so-called smart plugs available, right? What is a smart plug? Well, it's just a little thingy which you plug in between the wall socket and your device or some distributor thingy. And ideally, it has a couple of functions, like you can switch it on and off remotely, of course. Then you should also be able to monitor your energy consumption, say give you a reading in terms of watt or something like that of the current power use. And then ideally, it also should be able to log everything for later analysis. The problem, of course, is if you go to your favorite e-commerce website, you will find something like shown here. It's very cheap, you know, and it says indoor use only, that's fine. But it also says compatible with Alexa. And here already comes the problem, because I want to use my energy usage, and I do not necessarily want to have Jeff Bezos monitor this as well. So I was thinking to myself, okay, are there any alternatives? Is there anything which I can use which is running locally? And it turns out, yes, there is actually some alternatives. There is a no-cloud alternative. I found a product, something like this here. This is sold by the German company Conrad, but I'm pretty sure more or less exactly the same device is probably also available from other vendors under just a slightly different branding. What's nice about this smart plug is that it's Bluetooth only, so it does not connect to any Wi-Fi, no network required. It does come with an official iPhone and Android app as well, which is nice, I guess, for people who use this, but even more nice is that there is an unofficial open source code available also on the internet, already done, so that you can connect to it and then you can do everything, switch it on, switch it off, do the energy use, and all that fancy stuff. Side note, these things, they are really expensive. So you've seen the Amazon device, it was like €9. This is more like 40, so 40, I kid you not. But I guess that's just the price of freedom in a sense. So I already told you there is a lot of code available already. So I found this expect script by a guy called Hacky75 on GitHub, and it really does all the hard work, so to speak. So it connects to the thing via Bluetooth, and it lets you access all the functionality of the device. Well, how am I going to use it? Oh, okay. Yes, okay. So I made a little drawing here of my architecture, so to speak, because I told you at the end of the day I want to monitor my energy, right? So there is the device somewhere plugged to the wall, and then it connects via Bluetooth to this expect script from Hacky75. Eventually, I want to log all my energy use to some time series database. I'm using InfluxDB here, and then it's all visualized using Grafana. And of course, in between, there's a little bit of glue code. This is this Python script that I wrote. It's not fancy, but it's still necessary because the expect script, it just gives you like a command line interface for more or less of an interactive use. But then, of course, I want to automate it, and I want to have it running continuously. And that's exactly where I had to do a little bit of coding. Now, keep in mind, I'm not really a good programmer. I consider myself much more of a tinkerer. But every once in a while, you just have to tinker around, and then you try it and you try it again, and eventually you have to make it work. So what did I learn along the way? Here just you see a little part of the code. It's not that important. I mean, I will show you a link in a minute if you're really interested in the code itself. But it's just a couple of lines, and it's not that fancy. It's just some basic stuff to make it work and to connect to the device and then eventually log it to the database. What did I learn along the way? Well, first of all, the Bluetooth device, it has to be set inside the expect script, actually. So my code cannot do this. This is something which you have to set in the other script. I ran into this issue because I have a very old laptop. The Bluetooth in my old laptop where this all is running is so old, it cannot connect to the devices, so I had to use a USB Bluetooth, and then I ran into this issue where I have to actually set the Bluetooth device in the script. What's also a very key learning for me is something like that. It will just run fine for some time, and some time can even mean like a couple of weeks even, right? It's doing all your stuff, it's logging, you get your nice panels, and it's all nice and swell. Until one day it's not working anymore. It may be crashing, or even worse, it might show you some bogus value like an energy consumption or an energy power. usage of 1500 watts for your desk, which is maybe a little bit excessive. So of course you have to fix this. You do a couple of technical solutions, you use queues, you use threads because you want to monitor more than one plug at a time. You use sanity checks for unreliable values, for stuck values, and all that jazz. So rinse and repeat, and eventually I ended up with something which is pretty usable and which is now running quite reliable on my own hardware. One caveat, security is not great, because basically if you know the Bluetooth ID of your devices, pretty much everybody can just connect to it. So in principle, my neighbors, if they're really nasty, they could connect like to the plug connected to my desk or my TV and see what's going on. On the flip side, at least you also see that the connection does not work anymore, because you can only have one connection at a time anyway. Okay, so what does it look like in the end? Well, this is a Grafana panel, and you see it gives me exactly what I want. This is here showing now data for 1 day. And as I told you, it gives me all the energy use, all the power for various devices. And of course, I can analyze this later. I can log it, and it does pretty much exactly what I want to do. And that's pretty nice. It's also running for me on another panel. So this is in my kitchen, actually. This is just some Raspberry Pi-based thing. So this is Raspberry Pi 5, I think, yes, with a touchscreen interface. You can see also a glimpse here in the left of the picture of my coffee machine. I think there's the microwave on the right, also barely visible. And it gives me all these nice statistics. The temperature, this is of course not coming from this. This is something separately, but I think you get the idea. Now, of course, in the end, we have to ask ourselves the question, is it all worth it in the end? Because ultimately, this was a lot of work, a lot of coding and trying to make it work. And you have to set up the hardware, and you have the visualization and the database. And it's also, for sure, more expensive than just getting something off the shelf from whatever cloud company you trust or not trust. So of course, it's always the question, right, if it's worth it in the end. But for me, I mean, it's definitely worth it, because this is all open. It's all open source now. I mean, even the script itself is open source, because I put it on GitHub, and I have complete control over all of my data. And I think in the spirit of Carolina's wonderful talk, for me, it feels very nice. It gives me a very good feeling. And in that sense, it's very much worth it. So that's all. Thank you very much for your attention.
Thank you, Christian. And that was our morning segment. So to continue with what I was saying about the lightning talks, the next best thing about conferences is the so-called hallway track, where you mingle and meet new people and maybe ask the speakers some questions. So to recap, you can ask Ada about slides, Carolina about scratching itches, Martin about French words and cheeses and package indexes, and Christian about home automation. So if you would not like to do that, then you can also get coffee. Upstairs. Yeah, sorry. Upstairs snacks already. Nice. Okay, so the coffee break has officially started. It will end at 11:24 with the next lightning talk. Have fun. Make it fast.
Now? Okay. So, hi. My name is Kuba Beranek. I teach programming at the local university, and my main job is contributing to open source. So I'm a member of the compiler and infrastructure teams of the Rust project, which develops the Rust language and its toolchain. And today I want to talk about tests. Tests are great, right? It's a great feeling when you run your test suite and everything is working as fine as... Wait. Let me try again. Okay, probably some flaky test. Anyway, as I said, tests are great, right? Like they allow us to find regression sooner in the development lifecycle. They give us more confidence when we make refactorings to our code, and they also help us develop new functionality. But at the same time, tests also kind of suck. They can be difficult to maintain, to understand, it can be difficult to reproduce failures, and this can be causing stress, right? When you receive an email that your CI workflow has started failing all of a sudden. So I would like to share some tips to make tests less annoying. And as a use case, I will be using a GitHub merge queue bot, which is an HTTP web application that you control through commands on pull requests, and it merges pull requests for you. It's actually written in Rust, but I will act like it is written in Python for this talk. So the first annoyance is when tests break during refactoring, right? Ideally, tests should break when the behavior of your app changes, not when you change its implementation. So I do a refactoring, then I fix the compiler or type checker errors, then I run the tests and they fail. And this is quite annoying. So why does this happen? Well, I think it happens when we write tests directly to the internal API of our application, because then when the API changes, it will break all our tests, right? And if you have like 300 tests like this, you will have to change them. And sure, IDs and AI can help with this, but it's still annoying. So I think it's better to test the public interface as much as possible and test the behavior, not the implementation of your app. Online, we can find these like test pyramids that tells us like we should write as many unit tests as possible and then a small number of integration tests. I think that it's not the best way to do things, and I tend to write as many integration tests as possible because those give me the most confidence that my app will be actually working. And I really love this quote from Alexei Kladov, which tells that your test suite is high level enough if you can replace your whole app with a neural network, and your test suite will still be working. So if I would be testing this merge queue bot, I will be testing it on a completely end-to-end level. I would just start the application, communicate with it with HTTP endpoints, and if the implementation of the app changes from Rust to Python or C++, the whole test suite ideally should be able to be reused. Another annoyance is that tests are hard to understand. Like recently I was implementing some data structure, and you would think that testing a data structure is the easiest thing ever, right? Like no dependencies, it's a simple thing. But actually, even if a test has like 10 lines of code, it can be quite difficult to understand what is happening there. So I usually look like this when I'm trying to understand some tests. So my tip for this is to make tests visual, right? Like, what if we took this data structure and we rendered it to a string? And now it's completely obvious to a human how does the data structure look inside? What are the pointers and the state? And it's much easier to understand. Now, you might be thinking that it's pretty painful to maintain a test suite like this. And sure, that's another annoyance, to actually change the tests when the behavior changes. And a tip for that is to make tests data-driven and use snapshot testing. So actually, I wasn't creating this string by hand. I could be using, for example, PyTest Insta, which gives me this snapshot thing. And when it runs for the first time, it will actually take the output, store it into disk, into a so-called snapshot. And in the future, if the test changes, I will have two options. I either change the test, which will do it for me, or the test stays the same and there is a bug in my application. Another annoyance is that I don't have enough confidence in my tests. They are green, but in production it fails. So I think the best way to battle that is to test the real thing and don't overuse mocks. So recently I was reviewing a pull request that was quite big. It had a lot of tests, but all of the tests were essentially just creating a bunch of mocks and then testing one function that it works with the mocks. And that was like completely useless. I just told the author to delete this test suite because it wasn't worth it. Why do we create these mocks? Because we have dependencies, right? We have something like a database, and then we don't know how to create this database in the test. So what we do, we create a mock. We create a hash map instead of a database, and we use it in the test. And what we get for this? An production crash, because Postgres, surprise, is not a hash map. So I tend to actually run my test against a real database. You can use, for example, PyTest databases to give you this nice picture that will give you a clear database with all the migrations applied, and you can run your application against an actual database. Now you might be asking, isn't that slow? Sure, it can be. We can run tests in parallel. We can disable durability in the database to make it faster. But even if integration tests are slower than unit tests, it is still much faster feedback than when your app crashes in production. And this extends not just to external dependencies. Like, we write our applications in layers, and there's this unit testing philosophy that tells us to test each layer in isolation and mock the rest of the world about it. I think that's kind of sucks. I think that we should always be testing the given layer and all the layers below it together so that we can actually test that they integrate together and that they work together. Now, we can also test in production. Like, that sounds a bit like surprising or weird, but I think it's very difficult to emulate the production environment in staging, so why not just test in production? But this doesn't necessarily mean that you test on real users, right? Like, we have these things like feature flags. It's a pretty simple and stupid thing, just an if condition, and you will use the new functionality only for the admin user or a test user, but you will be testing it on a production environment, right? So that you know that it works there. Another thing is compile time tests. This is more relevant to languages that have static typing like Rust, but even in Python, every type hint that you write is a little test that, if you run a type checker on CI, will give you very quick feedback if you, for example, pass the wrong type to a function, and it's much quicker feedback than when this crashes on production. Another tip is to use asserts liberally, right? Like, this sounds, again, obvious. We use asserts in tests, right? But I'm not actually talking about tests. Like, everything that we cannot encode in our API, or the type hints at least, ideally, if it's important, we should assert it in our code, because it multiplies the value of our test suite. Every time a test goes through this line, it will check something about our application, if it is correct or not, and this actually improves the value of all your tests. Another tip, you can test pretty much anything. You can test that your migrations can be applied to the production database before you actually try to apply it on production. You can test if your code is properly formatted. You can have it in a Python test rather than in a YAML workflow that is not really easy to run locally. You can test if your dependencies contain compatible licenses. That can be a test. If you don't have some weird commit in your Git history, or if the example config file that you have in the root of your repository can actually be parsed as a valid config file, and you don't have some old config options that are no longer even valid in your application. So my final annoyance here is that CI can be green in pull requests, but it can be red after merging. And the author of Rust, Graydon Hoare, has this nice rule about this that is called the not rocket science rule of software engineering. And it tells us that the base branch should be always green. It should always have passing tests. And again, that might sound obvious, like we all do this, right? But actually, not really, because it's not the default on GitHub. When you have multiple pull requests and they have green CI, and the first pull request is merged, and the second pull request is merged on top of that, the tests can suddenly break. Why? Because we haven't tested the second pull request on top of the first one. So there is a very easy fix for this. Just use merge queues, or on GitLab it's called merge trains, because they will ensure that every time you merge something into the base branch, all the tests have actually passed. And even if you do all of those tips and resolve the annoyance that I talked about, things will still fail somehow, so it's good to make peace with it. So a fun story for the end. I was working on a different Rust bot, and I noticed that it didn't give me any error message when I didn't give it the proper command. So we implemented a fix for this, but sadly, here we didn't have any integration tests, and the error message did something pretty stupid. It tagged the bot itself in the error message. So when there was an error, the bot said to itself that there was an error, which itself was an error. So the bot kind of started talking to each other, and this lasted for like an hour before its GitHub rate limit ran out. So yeah, even if you have all the best tests in the world, there will still be some things that you cannot ever test for, so it's good to make peace with it. And because I have a little bit more time, let me show you some final annoyance, and that is test metrics. So sometimes on the internet, I see things like, we have only 90% test coverage, but we want to reach 100%. And I think that this claim is, like, it can only be made by someone who doesn't understand what line coverage actually is. So when we would plot like the line coverage percentage that you get from various tools on the y-axis, and on the x-axis, the situations that are covered by all the possible situations that can be covered by tests, it will look something like this. So 90% coverage will be here, and 100% coverage will be here. But all of this will also be 100% coverage. So if someone tells you, I have 100% test coverage, well, they can be here, but that is quite unlikely, or they can be here. And in that case, it doesn't really mean all that much. So metrics can be useful, but I wouldn't worry about them too much. So that is all from me. Thank you for your attention. And I would like to call out that these slides were created in LZ, which is a previous generation of ADA's slide creation software.
Thank you, Kuba. Do we have the next speaker? There you are. Hello. Hello, hello. So, Łukasz is getting set up. Meanwhile, let's see. So, Łukasz's talk will be about the quest for bad apple on an IKEA display. There's a Swedish word. I hope you know how to pronounce it because I have no idea. Oh, hardware talk. Nice. There's something special coming up. Hopefully it's just HDMI for the display connection. So it should be easy, right? So this is why we have the 2 minutes between the talks, so we can get all set up, mic'd up, and so on. And oh, hello. Somebody's late.
You don't have any thing for.
All right. Almost done. All right. So, who has read the title of the talk and looked up what kind of hardware this is? One or two? A notebook? Maybe. Well, it's a display, so it's probably something that shows images, some kind of images. Who's familiar with the bad apple? Really? 2 people. Oh, well. Now you'll need more time to explain that. Are you ready? All right. So, well, we're almost done, I guess. There we go. There's a slide. There's the speaker. There's the mic. This is Łukasz.
Started when I went to an IKEA store. I found a display that was with a really good bargain, as you can see here. I wasn't really interested in the animation because, well, it wasn't really interesting. What I thought was maybe I could start to reprogram it and do something fun with it. So I wrote a friend of mine I sent him the video, and his only reply was, take it. Well, so I did. Then I started wondering how to reverse engineer the protocol to access the LEDs, but then I find out that someone on the internet has already done this for me, so, well, great. He posted it on GitHub with a full explanation on what to do, what to solder in, what to solder out, and how to do that. So, well, yeah, and the only thing that I needed was to buy an ESP32 microcontroller, which I did, and I started prying open the back case. I removed all the rivets, which took me more time than I care to admit. I had to solder some wires here, desolder the original microcontroller that you can see at the very bottom, this one, and in the meantime, I got my ESP, for which I am totally authorized to handle it, as you can see, because I'm not personnel YX, whatever this means. I put everything together and went with my friends to the KS Communication Congress to set it up. If you don't know what the KS Communication Congress is, it's a big conference where if you have a few friends, you can get an organized group, you can get a small table or 10 to put up your stuff to show off, etc. So that's what we wanted to do. But yeah, as you've been already asked, you don't really know what a bad apple is. So really quick and incomplete story. Well, a guy starts making games. He's a musician, so he puts some music in it, his own music. The games become popular in Japan, and one of those musical tracks gets a remake with a professional musician and singer. That tracks becomes even more popular, and one fan uploads just a storyboard to a video site with his mention like, someone please do this for for some kind of animation that would go with the music. And guess what? Someone actually does, and it's really good. It has a catchy tune, an interesting animation that is composed of only 2 colors, which means that everything that's on the animation is really visible, and that's made it perfect for like demo scenes and like, where people just wanted to show some kind of animation on a display that was not meant to actually display things. On the internet, if you start googling for Bad Apple, you get the Bad Apple animation on Minecraft sheep, on Windows. You get it on Rubik cubes, on 3D printed elements. You have Bad Apple on an oscilloscope, Bad Apple on bad apples, Bad Apple on good apples. Well, everything. So basically, it's just like with Doom, If there's something that can compute something, you ask the question, can it run Doom? If it can display, or seems to be displaying something, you ask, can it display Bad Apple? So we wanted to do just that. We started with the animation editor that's included with the firmware of the thing that I found on the internet. But yeah, manually drawing everything would be really tiring. So we tried the REST API that's available. We took the example from the project, put something together, started sending data over UDP packets, but then we needed actually to obtain the source material. So how would we do that? So this is where Python comes in really handy, because we have the YouTube DLP program that's written in Python actually. That can be used to download the videos from YouTube and other sites. You have FFmpeg, which will then be able to convert that video to frames, and Python in general that will be used as a glue. And as you can see, it's really, really easy. I'll show you how we did it. So the first thing that we did was we imported all the required packages, and then we stole the frames from someone who did the job for us and uploaded it to the internet. So yeah, but we needed to do it fast because we were at the conference. We didn't have time. We hit some small issues, like it turns out that if you open a UDP socket 6,000 times, it takes some time. So we managed to optimize it here and there. But then we hit another problem. Well, the display was doing something like that. It was frozen and blinking. So we tried to debug. We decreased the size of the animation to figure out where exactly it was crashing. And it turned out that it was crashing when there were a lot of pixels that were shown on the screen. So we just switched to another USB charger. Yeah, and it crashed again just later. So we decreased the brightness, but it crashed again. So we figured out it's just like, power. Playing with power is just like violence. If it doesn't work, you're not using enough of it. So we put the beefiest power plug that we could find, and it was kind of working. And we let it run for half a day at the conference. But then, as you can see, something different started happening, and we didn't really know what it was. It was really choppy again. And then it hit us. We checked the network manager, and we realized that there were literally hundreds of access points at the conference shouting around us, sending packets. So it was back to the drawing board. We went back to using the animation editor. We figured out that we could just import something, like import a ready-made animation. And we repurposed our script that was sending the UDP packets to just dump all those packets to a JSON that we loaded to the animation editor. And then nothing happens. Okay, let's try to debug it, send fewer frames. Still nothing. But since they were working as before, we kept going. And when we ended up with an animation of 10 frames out of the 6,000, it started working again. Okay, so it turned out that this was too much data at once for the software to handle. So then, Gwynblad, the guy who's actually doing the streaming, wrote a small C++ patch for the firmware that allowed us to append an animation, like append frames to already done animation, so that we wouldn't have to send as much data at once. But then it worked for 200 frames. Okay. Okay. So we decided to go the atomic route, which would be to write our own plugin for the display in C++. We put everything into one vector. Like, as you can see, we included the bad apple file header, and the header was something, the thing that you can see on the right, just data. And guess what? The compilation fails. Okay. We tried fewer entries as previously. It failed again. We tried to use a bit field instead of storing the like floats with no brightness information at all. So either the pixel is lit or it isn't. And it finally worked for 500 frames. And I would love to tell you that we've managed to find some magical trick, but actually not really, because we were slowly running out of time. So out of desperation, we just use the DLSS thing, which is to create fake frames. So actually, we skipped every second frame, and then we got to 1,000 frames. So the current state, let me show you how it looks right now. Let's hope it doesn't fall down. So that's our animation. We have 1,000 frames out of the 6,500. We also tried, by the way, doing run length encoding and just marking the pixels that have changed, and it didn't really help, sadly. We have future plans to improve the this for next year, let's say. Yep, these are the ones. And also we need to figure out how to do remote development, since there's 4 of us and we only have one display. So yeah, thank you very much. And by the way,
thank you, Łukasz.
Yeah, one more thing. This display, we'll put it somewhere, maybe up there. So if you go to HTTP this display website, you could toy with it and maybe write your own functions to send the UDP packets to play with it. Yeah, so it will be here for the day.
All right, so that's for the next coffee break. Thank you, Łukasz. That was amazing. I'm looking forward to looking at this. And the next speaker is Janusz. Did I pronounce that correctly? All right, so here you are. Please get set up. One thing I will be asking Łukasz is, what is that thing called? Because I haven't heard the pronunciation of the name.
Obegransat. I hope so.
Okay, that, yes. Yeah, I know how it's spelled, but it's Swedish. We had a French word before. We have Swedish now. I wonder... oh, well, all the names of the speakers are in Polish. Yeah.
I'll be fine.
Me? No, with names, yes.
Well,
technically, yes, I do need help, but if I mispronounce them, it's more funny, right? And that's what I'm supposed to be here for. Telling you jokes, except I don't know any jokes. Are you ready? That looks fine.
I think I'm ready.
All
we can get
right.
there.
Janusz.
Thank you. So huge production goes down. Postponed release, angry customers, angry users, and not to mention the team, which is under high pressure. We all been there. We've all done that. And this will be a story like this. So basically, meet the crafters, the developers team, which are working on the web application, which is running in the cloud on multiple instances, some of which are Canary instances. So basically deployed early. They're running this infrastructure using the configuration repository where they have configuration for the web server, which they maintain, but it inherits from the core web server configuration, which is maintained by the team they call the DevOps team. But let's call them vtenders. So 2 weeks ago, they deployed a new version of their application to the Canary instances. And with the new application, also new operating system was deployed by them, because that was their choice. Everything was fine until a week later, they started to get memory leaks on their application. The new version, right? So they had to jump right into it because for the next week, they already announced the release. So it's like, there's no way we will postpone this. No way. And it actually took them another week to figure it out, and they found the fix just 2 hours before the release. Yay! So what happened was that in their web server there was one configuration which was optional, but it was running on the new operating system, causing them memory leaks, while at the same time on the old operating system it wasn't there. So it was like, okay, it's optional, let's remove it. And they did. And memory leaks were gone. Yay, we are 1 hour to the release, we can release, right? Nothing's going to be wrong, except the production went down. Yeah, okay, so they made a call together, like meeting, and they invited one of the people from the tenders team, because it's like, okay, it's a disaster, let's call them in. So this person joins the meeting and is like, okay, guys, but you know, this configuration on the old operating system, it's actually there, but it is very customized by us. And, oh, you're deploying the new operating system, good to know. We're not ready for that yet. Okay, let's fix it. So the thing is, when you remove this configuration, it actually got removed also for this web server on the old operating system. And it was mandatory, so this web server is gone. So this is what happened. Now the fix is easy because we can revert changes. This is the code repository code for the configuration. And yay, we have production up and memory leaks are back. And we are 15 minutes to the release. Okay, let's postpone it. Customers will be angry. But since they were on the call together, they decided to look into the actual root cause of what happened. And what turned out to be was that a week earlier, someone from the tenders made an update in this configuration. And they had no clue that this configuration change may impact also a new operating system, because they were like, nobody's going to deploy the new operating system, right? Right? So when the next day they didn't connect the dots and they noticed the memory leaks, they were like, oh, it's in the application of crafters, let's file a ticket. And crafters started working on this, going back and forth over the comments in the ticket, and they were like waiting for the tenders to reply 24 hours and so on and so on. So, you know, the rest of the story. Now the thing is, their company created this DevOps team because they wanted to have automation, monitoring, and basically adopt DevOps, and it worked great, right? So, yeah, they did DevOps, or maybe not. My name is Janusz, and I am a Python developer on a daily basis, but also for the last decade or so, I've been organizing DevOps days in Poland, and I heard plenty of stories like this. So, when companies create a DevOps team, they usually are like this. They mean good. They are like, let's do automation, let's have monitoring, let's have more super cool technology stuff that will help us deliver faster and more reliable. But at the same time, what they do indirectly in their organizations, they tell people something like, so these are the guys that do DevOps, so you don't have to. And by mistake, in a way, they actually kill the DevOps adoption on their organization that way. So instead, they should foster the DevOps mindset across the organization to everyone. When you, and we will see in a minute how it is done and why it is not down to one team only. So when you take one of the DevOps implementation frameworks like Cora, the Dora core model, you will see this capabilities catalog, which is basically a set of good practices and stuff that you should implement in your organization to actually implement and adopt the DevOps in your organization. And sure, we will have here things like continuous integration, deployment automation, but there are basics which are often missed, like cultural shift, which is under generative culture, or it's rather generative organizational culture. And some of them you may know, but we'll focus on these three, because these are the most important ones for today. And let's start with high cooperation, which is basically about building the cross-functional teams, which means you will have developers, their engineering manager, product manager, BA, QA, but also operations like scale, cloud engineers or system engineers, and even security experts. Because then all of these people can work together to make your product, for now, let's say product, more reliable and secure and deliver it faster. And since these people are working together on one team, they are actually breaking down the silos, because now this guy is working with me on a daily basis. I know what's going on with my product. So when I have these people in my team starts to be fully aware of what's going on around us, because everyone has their own perspective on the product, on the things that we deliver and how we deliver these. But also, these are different angles. And this connects with another famous infinite loop of DevOps, which is like the stages of the process where you go from production of the value, let's be more generic here, to operation of the value. And when you go through these stages, usually companies are like, okay, we'll do deployments, let that one particular team be responsible for deployments. So they are splitting the responsibility of particular stages instead of giving the whole process to the team, one team, which will share the responsibility. So this is the difference. Why? Because that way, people who look at the same thing from different angles, they can actually start working together to speed things up. So basically bridging the gaps between the stages, increasing velocity of each stage. Namely, they accelerate the value delivery over time. And when they start doing this, eventually they start to feel like, okay, now we truly know how to build this product, we know how to run this product, we decide how it goes. So they start to grow ownership naturally over their product, or in general value of this, of what they deliver to the business. And this ownership is growing naturally instead of being enforced by company, again, like, this is your responsibility, you own this. There's a difference, right? There are multiple other benefits, but we'll skip this for now. So sometimes people say, okay, now I'm in this team and I need to know everything about everything, basically, and everyone needs to do this on the team. Well, that's not true. On contrary, it's like everyone on the team needs to know how the process goes, how it connects, and who's doing what, because people are experts in their own areas, but it doesn't mean I have to know everything. They are just super close to me, so it's easy to reach to that knowledge and expand it in my mind also. So it's not about knowing everything about the process, but rather having the team as a sum of all experts knowing everything about the value that we deliver together as a team. And that way, using cross-functional teams, you can actually adopt the DevOps in your organization and avoid disasters like the one you've seen. That's it.
Thank you, Anush. And now we will be waiting for the next speaker, Jirka. There he comes. I see another laptop full with slides, so it will take a moment to set up. All right. So, do any of you do DevOps here? Oh, a lot. Okay, so they're all on that side. It's weird how the sides of the room are so split. Or maybe there's just much more people here. How many of you do stuff with AI? Now it's more even, I think. Okay. So this talk will be about the taxonomy of AI frameworks, right? And your slides are, is this your slides?
Yeah, but
All right,
apparently
you're ready.
yeah,
All
but
right. Yeah, that will happen automatically. So for all the speakers, your slides will be there.
Yeah, but
and they'll be set up automatically.
they're not.
Oh, this
That's
is not your
that's
slides.
my background.
That's your background.
What you're seeing, these are my slides. What was on the screen is my background. It's apparently detecting this as a second screen.
You need to do something technical there.
Okay, I don't know where the
reroute the
there it is.
display output to the correct device, right? The pixels need to go through this cable, I think. Yeah, the correct pixels need to go through that cable. Otherwise, we'll see a black hole or... What was that on the screen?
That was a galaxy, but whatever.
It was a galaxy, but that's a
There
different...
is a substantial difference.
That's a different talk, and it's probably longer than 10 minutes.
Yeah, slightly.
All right, now these are slides. All right, Jirka, take it away.
Okay, after a slight delay, we are finally online. I will talk to you about taxonomy of AI frameworks, which is a highly arbitrary topic that I just made up. Okay, not entirely, obviously. Taxonomy has a long history, probably from Aristotle, although at its core, it's basically just that we have some objects that we know are different somehow from each other, but share some traits. We want to give them names so we can talk about them without, going insane. We want to share some information quickly, and we want to, conceptualize some approaches to them. By the way, that's even in Bible, in Genesis, one of the first things Adam does is just he names a bunch of things. And obviously Carl Linnaeus was the one who brought us the modern taxonomy with all the nice genera of plants and animals. We'll try to do something similar here with AI frameworks. First of all, let's establish what we're going to talk about. It's a library or a set of libraries for development of AI-based software. It's not a finished product, so it's not an application you install, it's not a chatbot, it's not an agent like Cursor. It's something that you use to build an agent or a chatbot or something like that. It's not necessarily just LLMs, but due to the way the conversation has been shaped for the past 4 years, it pretty much is now, so unfortunately. Due to the number of things I'll be talking about, various projects, there is a high probability that I may hit upon something you have contributed to. Please in no way interpret the things I'll be saying as in any ways judgmental towards the project you may or may not have worked on. It's just my personal opinion. It's just my judgment, if anything. So let's jump in. As all taxonomies, even mine is going to be very arbitrary. So I'm just going to focus on 2 criteria. Aristotle focused on number of legs and whether or not it has a blood or, hasn't. I will try to focus on the origin, so who made it, and the level of abstraction, which I would describe as how difficult it is to actually develop anything with it. If you need to know linear algebra, yeah, the level of abstraction is somewhat lower than if you just need to know an API set. And we'll start with the origin. I'll focus on 3 possible origins, and I do understand that there is a way that one project can move from one to another. But in many ways, projects inherit or keep their heritage even many years after they have moved on. So you have projects that have started as commercial ventures, then they have moved on into being fully FOSS, possibly under the umbrella of Linux Foundation, but they still keep their origin very much embedded in how they're managed and how they work. We'll start with the first one, which is the category today after the LLM boom. That's all the frameworks that were created by startups since 2022. Now, most of these companies started either in the past couple of years, or they were very much new companies and small companies before, and they decided to cash in on this, right? So we have engineers, we have some know-how, let's make a product. The problem with making a product is that when you're a startup, initially it's difficult to sell things. So a lot of those startups decided to also make sort of like public, FOSS-y, not exactly completely FOSS in management, but FOSS as in, free open source software part of their offering. So people can actually demo it, build their own projects on top of it, and later, when they finally decide to commercialize the whole thing, they can, get some money. And overwhelmingly, this is tied to the concept of LLMs. Even more, it's often tied to concept of OpenAI APIs, although there are other options as well, but OpenAI API has become sort of a standard for some reason. I don't know why. We'll start by a couple of examples. So the first one I have here is LangChain or Langsmith. Anybody worked with LangChain? Okay. So LangChain is exactly like pretty much the prototype of a company that tried to make it big in this area with FOSS offering and with their own commercial offering. Langsmith is like the commercial part. The LangChain is the part that you get for free. Although you can also demo Langsmith with like a free license or something, but it's limited. The interesting thing about LangChain is how it tries to do almost everything you can imagine and then some. So LangChain has adopted a model where the source is basically open source. The management is kind of not, definitely not actually. The direction of development is what they decide on. The community doesn't have that much input. You can obviously submit a PR, you can ask for a feature, but they decide what the feature is, which features are going to get adopted, and how they're going to work. And obviously, one of the things when you're a startup is that you will have to start making money at some point. So you can't implement free features that will collide with your commercial offering in some way. If you do that, you're basically stealing money from yourself. You have to be very careful about what you eventually implement. It's not that you can't implement these things at all, but if you implement them too well, if you document them too well, nobody will want to pay you for support. So you have to be kind of careful. I'm not saying that this is a motivation for somewhat convoluted dependency chain in LangChain. I'm just suggesting it. That being said, LangChain is definitely one example, and it goes even deeper because apart from LangChain, they have also developed LangGraph, which is dependent, dependent on LangChain. And on top of LangGraph, they have developed deep agents, which are dependent on LangGraph and on LangChain. And LangChain has a whole bunch of sub-packages with different capabilities, and those depend on a whole different set of libraries from third parties. It's a mess. Then we have another example here, which seems diametrically different, but it shares some significant overlap. A light LLM. Has anyone here used light LLM ever? Okay, so light LLM takes a radically different approach. It's also a startup, effectively. They have their commercial offering, they have their public and FOSS offering. Light LLM is basically a wrapper around all the different LLM-like APIs, and it makes them look like OpenAI API. It's very simple idea, but exceedingly useful because that's what most people are used to, and also it's very manageable. you don't have to learn much to use it. It's basically just a library that makes calls to API. And you could ask yourself, how do they want to make money from this? Well, obviously, if you are using something like this as a router for LLM calls, you can use it to manage permissions and allocate quotas for tokens and a whole bunch of other stuff. And if you make this sort of identity and permissions management complicated enough, you can actually ask people to pay for it. So that's the model Light LLM has chosen. Just like with LangChain and all the other frameworks under this category, the development is only partly FOSS. You can submit your PR, you can ask for features, but they decided on the direction. So you have to keep that in mind when you're working on it. You have a second type of origin. That is existing corporation. Yeah, I'm running out of time. Fuck. That's like my 10th. That's my 5th slide, okay? Okay, the point is that these also accept FOSS contributions, but they usually keep it even more tight, but they don't want to make money from it. Not necessarily, because they have plenty of money already. That would be like BAI or LlamaStack. By the way, in AI space, Meta isn't evil that much. And finally, we got origin from FOSS or academia. That would be PyTorch. Again, that's kind of Meta, but it originally is from Swiss universities. And we got Llama CPP and GGML. That's definitely FOSSy. I'm out of time, really, right?
Yeah, to be continued.
Okay, sorry.
So if you're interested in how the story ends, you can find Dirka at the lunch break. I think it'll be long enough. Or maybe you should publish your slides. Ooh. All right, and now we have Mojžiš. Who will be saying how to do stuff in 2026? Always seems like there's only one answer to how to do stuff in 2026, right? But hopefully this will be different.
Hello.
This will be about music, and I'm happy to say there's another piece of hardware to show. All right, and the setup is more complicated because it's not only pixels, it's also sound. So who can guess the genre of this song? Jazz. Yeah. That was a guess, yes.
Yeah.
Are you ready?
Yes.
All right. So this is Mojžiš. How
Hello.
to make music with Python.
Yes. Hello, everybody. Happy to see you all here again. They feels like my birthday. How to make music with Python. I've been doing this before, music. So, to make music in Python, let me give you a bit of the agenda. So I'll talk very briefly. I have like very few slides. Disclaimer: Super Collider, Fox Dot, Renardo, Sardine, and what to do next. So this is me. I've been toying with music and coding for the last 6-7 years. Not all the time, but sometimes, and then I usually do this at conferences. One thing that struck me lately is, like, I was listening to some Daft Punk, and there's a quote there in the song by Giovanni Giorgio, which is kind of like the father of disco. And he says that once you free your mind about the concept of harmony and music being correct, you can do whatever you want. So I used to be very stressed about making things like very precise, being like very correct, playing the right note, and so on. But once I got rid of these chains, I started to having more fun, basically. Super Collider is the engine behind everything. It's not Python related, But SuperCollide is an open source synthesizer. You can use it to define instruments, and basically it's what every other solution around music encoding is using most of the time. So we need SuperCollider to run. And there are 3 different Python things. There is Foxdot. I first came to know Foxdot in PyCon CZ 2018, I believe. Then after that I started doing some music encoding. Foxdot has been archived. The maintainer, I think he archived the project back in 2021. I was happy to find out last week that there is a new release in 2025, which he just like made it compatible with recent versions of Python. Some other guy picked up the project, he forked it, and it's called Renardo. So the syntax is kind of like the same. But for this one, I had a lot of pain to try to make it work. And there's also Sardine, slightly different syntax, and different ways that you can make sounds. While Foxdot and Renardo is very like what they call like the player, like you assign a sound to the player, some text to the player, and it will play it. In Sardine, you can have different ways of composing your code. So let's get to the practical stuff, and I still have time. That's good. So let's get rid of the slides. As I mentioned, this is SuperCollider. I will start the server. It works. Output. Is it? So let's see if it works. So this is my editor, and this is the test. Sound, yes. So basically, I'm assigning to the K1 player this instrument called pluck, and I can stop. It plays the given note. It can play a sequence of notes. If you know the correct notes to play, you can do a chord. If you do a tuple, it's polyphonic, so now we're playing all of them at the same time. If you try to do math, it will break, as you can see in the logs. But if you make a pattern, you can do math now. So basically now you can like transpose your music. I can also call stop directly instead of hitting Control period. I have different instruments. And we have samples. So samples is like a string, and every character in the string is a different sample. So this is a kick and a pause. Not a kick. So try this one. Not playing. Well, sometimes it plays. Okay, let me go to my next example, which I wanted this one to actually play. I hope this one would play. Why is it not playing? SuperCollider. We kill things. Kill. And then we start again. Error. Let's see if I can fix it. Let me keep the servers again. Or we don't want it to be for the next conference. Okay. Let's see if we can play something. Sound, yes. So I have connected through like a synthesizer that I can just like play something on Python and play something here, because then I can do and Python, right? Where is this? Stop. Yeah. Stop. Finally, what else can I show? So every time like I hit Control Enter, it's a good practice to have like this like comments, because it makes all the block connected. So when I execute this, it executes everything until the first line there is a space. So basically, when it flashes, it's executing from the top to line 15, because it's connected with the comments. I have some functions. I have a sample file there. See if I can desample.
Python.
I got from a friend of mine. Let's go back to the code, and let's see if it plays. This was the opening sound for Python Brazil a few years ago. So basically, you have control over the music on the execution when you want to like instruments to come in or not. And we still have a minute and a half. That's nice time for music. So this is one of the functions that we had up there. Like all these different samples playing. Here I have the sound, and then you have like the duration of the sound. The panning is like in which speaker it will come, if like a stereo sound. Amplitude is like the volume. And what I like on this upgrade, like going from Foxdot to Renardo, now I'm using an extension on this Pulsar editor. For Sardine, you have a VS Code extension, so you can do in VS Code. And I can have access to multiple files, so I can go inside other files and play some other instrument there, instead of having just like one screen that only one file open at a time, which was the state back with Foxdot. And we have seconds. If I go in a different file, is there time? I don't think so. Gonna be kicked out. No. Okay. Thank you.
Thank you, Mojžiš. So will this one be continued?
Hmm?
I guess not. All right, so that brings us to the pizza part of Python Pizza, which means the lunch break. Lunch is served, I think, already. I saw some pizza coming in. So you can start going up there, and the lunch break will take until 13:24. So you have an hour, get fed, then get back. Right. Did you enjoy the pizza? That was the pizza. Now it's back to Python. So before we start, I have an announcement about announcements. So at the end of the day, there will be some closing sessions and there will also be community announcements. So if you have a conference, a meetup, or something like that to announce, get in touch with the organizers. Martina. Yeah, Martina's the one. All right. And get your slides ready and so on. And with that, it's time to start the talk. Here's Tatiana with MCP.
Yeah. Great. Okay, so hi everyone. I hope that you love pizza. And today I want to show you how to bridge AI and Python code using MCP servers. We all know AI can write code, but can it run it? Can it execute your tests? Can it check your Kubernetes clusters? Can it check anything in your systems? And that's what we are going to solve today. Quick intro. My name is Tatiana. I'm a DevOps engineer. You can find me on LinkedIn. There is great, yeah, it works. QR code, and we can start with first part of naming of my presentation. It's mislink and AI. So we have a problem we all face with AI today, and it looks like this workflow. You call AI, it takes you some answer. You need to grab this, to copy this answer, open your terminal, put it on your terminal. You need to run it, you need to copy the result, you need to take it, the AI again and again, and this friction is disgusting, like, come on. And it's real limitation, so what if we remove you from this loop? And it could be with a Python function directly. So you can ask AI. AI calls function Python function directly. It could be not only Python, it could be Rust, any language. It doesn't matter. Like, we're on Python conference, so we use Python. Yeah, the function executed on your system, it returns some result to AI, and AI continue to reasoning it. So you don't need any simulation, you don't need to pasting, to copy, to switches, to simulate, to commit, to write any commands. So just call them, execute them safely, control it. That's what we are building today. And this is the result we need to get with the AI agent. And what is the AI agent? Like we daily using AI chat, but it has some limitation because AI chat you can only ask, okay, it can get you some answer, but you have only read only permission and just suggests some something. But what about AI agent? And this is what we're actually talking about today, because it could decide what to do. We not only read, but we also write. We can make action. We observe, we iterate. Without tools, there is no act. Without execution, it's just a smart chatbot. It's not real agency. So with execution, it becomes an agency that can actually do work. And keep in mind, no tools, no actions, no execution, no agency. So the question becomes, how do we give AI control execution inside your Python projects? We have a few different approaches. For example, vendor function calling. It look on AI provider. But it logged to one AI provider. Custom REST bridge, you built everything by yourself, your own web API, but MCP, it's something open, simple, standardized, lightweight, and this is the solution. But what is MCP? It's a model context protocol, and an MCP server is a program that exposes Python function that AI can call. So when you declare a function, you are giving to AI a control capability, and it's really cool. But we need to remember that we can we can catch context pollution. What does it mean? That if you generate a lot of MCP servers, you can lose a lot of context. So be aware about it. And our workflow will be looks like we ask something AI, and of course that you need to write some Python function. You decorate it with MCP tools, and that's it. AI can call it already, so nothing more. AI needs just if you want to check something, you can ask about AI, and it calls your tool, and your tool will run some command, for example, kubectl, I don't know, get some namespaces, and results come back to AI. AI analyze them and responds. So you are not giving AI unlimited power, you are giving it specific control capabilities that you define. So we have reasoning layer, where cloud decided what to do. We have execution, it's your Python code which does it, and MCP which connects them safely. Be aware, you are not giving AI freedom, you are giving it a structure power, and we'll talk about it next. For the today examples, I use cloud code. Cloud code is running in your terminal with agent capabilities. It can read files, run commands, and most importantly use with MCP servers. So our loop agent looks like think, act, observe, and repeat. And what we need to remember, it's about risk and about security. You don't need to allow him all of your systems. Don't allow him the deep levels of your operation system. You can only separate it like on Sandbox for only one project or for only one of the part of your system, but not for all, because with it AI agent could run very dangerous commands like rm-rf. We don't want to it. So today I would like to show you how simple this actually is. We need to import our MCP. Yeah, here. Also, we need to create some functions. here, and one of the important thing up of the function, we need to write MCP tool, which actually gives AI a option to call these functions. Also with it, we need to tell the AI agent where our server is. For it, we use this configuration. We need to remember that AI agent could suggest you to create this configuration within either naming, like only setting JSON, but we need to use cloud desktop config. Only with this naming, he will grab it and will know that, okay, I have MCP, I know where is it, okay, I can use it. And one of the important thing of this, cloud code couldn't call by himself. So you couldn't ask him to run this command. So you need to exit from your session and run it by yourself. You need to add your MCP to an agent. So you're with all of these passes, and only after it will be. Oh my God. Give me a second. Oh my God. Yeah. So, okay, we know how it works. We know how it how to work with it. It's only 2 slides. Only 2 slides. Okay, so we need to check our MPC in new session. Okay, it's connect. After it, we can call the first function, just add 2 numbers, and after it, the magic. Okay, you just can ask him, can you check if I'm using a VPN? Yeah, of course. Can you check if I have some Kubernetes clusters? Yes. You also can use it for your project to generate some README files and whatever you want. And why does it matter? Because you have only 13 lines of code, gives you real AI capabilities. The gap between conversation and action, MPC closes it. Thank you.
Thank you, Tatiana. Almost made it. All right.
Yes.
So let's make a short break today. Short break now. Milo, could you set up? Get the pixels going. So as you can see, it is snowing outside. It's more Christmassy than Christmas itself last year. So transport your mind a few months back. Jingle bells, lit up trees, presents, and before of that, of course, advent of code.
Yes.
So Miller will be talking
time.
about
Yes.
this coding
Thank you.
challenge.
This is my drink.
And
let's go.
Is that your slides? Nice.
Yes,
All right.
there are no slides.
All right. This is Miller.
Hello, everyone. Can you hear me? Hopefully, yes. So, my name is Miloslav Homer, and I work in IT as the IT security specialist. But today, I'm going to be talking about something completely different, which is Advent of Code. So for those that do not know, Advent of Code is a yearly event. It's somewhat like a puzzle set or capture the flag competition, where each and every day starting from 1st December, a new puzzle unlocks. Each puzzle has 2 parts. As soon as you solve part 1, part 2 unlocks. What is also remarkable in these setups is that there are some input data provided for you with an example result, usually. And also it's worth mentioning that they are language agnostic. Well, sometimes it's even shorter to solve them by hand on the paper in some more special and complex cases. So as I was solving through these over the years, a few patterns started emerging, and since I hate doing duplicate stuff, I was trying to optimize it all. So I wrote myself some code. It's not exactly a Python package, because a package is something that is somewhat static, so that you can distribute it with versions and whatnot. And that's not really what I'm looking for here. This is a live repository which is meant to be tinkered with, edited, and so on and so forth. You do see it. Hopefully it's readable. Let's go. So we have a command line tool that ties together all of the Advent of Code capabilities. We really want to communicate with the server as well, so the first thing we need to do is to log in to our account, which is the jankiest part of the whole setup because I was slightly lazy to set it up properly. So if you would like to use this, you would have to go to the developer tools to grab your cookie, which I apologize for, but it is what it is. Yeah. Ta-ta-ta, yes, that's me, perfect, we are logged in, clear. So after that, we can start with the preparations for the day. So we know that each day is going to have two parts. So we'd like to prepare some setup for a year that I didn't yet solve. And we can take a look at what we have. We have two files. So file 1 is the one that will be containing the solution to the problem. And it is quite simple. We know we have a part 1, we have a part 2. Usually the data parsing for the day is very similar. So there's a placeholder data parsing function as well. And alongside that, we have a test prepared, yes, this one, where, well, we use the simple test from the example, which also usually repeats. You can edit a couple of more parts here with the real values. And you have a test already prepared, which is great. So how this is done? This is done using Jinja templates. If you ever worked with some type of Python web framework, you've probably encountered Jinja. Django has something similar. They don't call it Jinja, but it's pretty much Jinja. So you should feel right home when using this. It's nothing really complicated, but it also gives you plenty of power to customize it to your liking as well. Okay, so we have set this one up, and now let's take a look at the web service that is communicating with the server. So go back here and let's open it. It's AOC service, right. So if you've ever implemented a web client using requests and the beautiful SOAP, this should look familiar. We start with the imports as usual, a simple class so that it's all bundled in one place and we can take advantage of the request session. One thing that is of particular note, the authors of Advent of Code asked nicely to provide a user agent that would refer to your toolkit and the solution. So we did. Then you also have to include the token for the authentication. It's just a single session cookie, so nothing too fancy. And then you can also use proxies if you'd like. And yeah, the API is quite simple. The most complex API use cases relate to the leaderboards, where you have to do some parsing and whatnot. But if you just want to get the users or get the inputs for the particular days, you can definitely do that as well. So a simple API, nothing too fancy. Please don't abuse it in a sense to hammer the servers. They are volunteers trying to make do. So then we have the library as we move on to start actually solving the problem on hand. And again, some patterns repeat, and as you are solving through the problems, you might want to have some problems solved because you encounter off-by-one errors. And raise your hand if you like debugging off-by-one errors. Really? Be my guest then, be my guest. But for the rest of us, there are some common functionalities that we have. Especially interested is the one that works with 2D maps. And what do I mean by a 2D map? So we've got these string objects where usually, but not always, the hashes are the obstacles which cannot be crossed, the dots are empty spaces which can be crossed, and the other letters are some points of interest. So I would guess that we want to get from point S, which should be start, to point E, which is point end, in as few steps as possible. Of course, there is some catch on that, but these types of maps and objects you will encounter on your way in Advent of Code in plenty different assignments. So it is lovely not to have debugging this each and every time you see one. There are other useful functions as well. like the intervals. And what I also like to highlight is the int code 2019 computer, where in 2019 you actually are tasked with writing an interpreter for a custom language. It's an awesome set of puzzles, because over the course of the days you are implementing a fully functional interpreter, and you can then run some classic computer games on it, like Breakout or Adventure. It's awesome. If you have the time, highly recommend it. So, and let's say that we have prepared all of our solutions. Now we'd like to actually, well, solve them and submit them to the service so that we can get our points and move on with our life. This needs to be imported. As you see, we are organizing the solutions in modules. So how do we actually do a dynamic import in Python? And I think this is the most technically interesting part of the talk, which we can see around here. So we are actually dynamically importing the solution. We've got a helper function that will return the function we want to call on the input from the advent of code. Also worth mentioning, I do not recommend doing any kind of preprocessing on the input. All of that preprocessing can be done within the solution, and it should, as to not break anything, and you never know when some type of detail would matter. So how is this actually implemented? So we are using the import function, but we are using the built-in import function with I don't know what these are called, but you know what I mean. You saw them before, you are all Python people. So first we need to find the path of our module. As I am having a quite strong convention with the years and days, this is not that difficult to achieve. And then we also need to construct the string of the function name, which we want to do as well. Again, the convention will carry me, because I know that in each file there is a part1 function and a part2 function that should take the raw input and produce the result that will be then submitted to the solution. And I'm actually faster. Okay, that is what I want to show you. And these types of features can then be used to build a plugin system to an application, which is something that you don't do every day, at least I don't. So this is what I want to show you. All of the source code can be found on my GitHub, and I will be sharing the links. So on the left, you have the link to the source code repository. You can view, you can star, you can fork, you can do whatever with it. It's completely open source. It works on my machine, so no guarantees. And if you'd like to contact me, here's my LinkedIn. And with that, I thank you so very much for your attention with 30 seconds to spare, and have a great rest of the event.
Thank you, Milo. And the next speaker, Robert. Welcome to the stage. Please get set up. So this talk will be about mob programming. Who has heard of the term before? 7 people, okay. Who has tried mob programming? 2 people. Great talk then. You will all learn something new. I don't know, to me mob is like a creature in a game, right? So you have the slime cube that you need to attack with your sword, but this is probably something different. And the slides are up. Robert, take it away.
Okay. Hello, I'm Robert. Imagine the following situation in your company. You have Jane, who is the only person who knows about the key API you are using. You have Mark, who is the only one who can approve PRs, or maybe 2026 version. There's another guy who is the only one who knew how to prompt the Claude code that operates everything. Yeah, the only one that knows how to do DevOps. In fact, knowledge in companies happens to be stored in silos. And every person often is a silo of knowledge, which is not shared with the others. So You can do many things with that. One of them is called mob programming. Mob programming has been, or the term has been invented by Woody Zuill around 2014, and it's an extension of pair programming. Who of you have at least heard of pair programming? That many more people, okay. So let's repeat what it is. Pair programming is not just two people sitting at one computer. It's a structured way of programming with two people at a computer, but each of them has a role. And if you remember, you probably don't because you are too young, when we were driving cars without the navigation, but there were such times, we required two people. There was a driver who was holding the steering wheels and just doing whatever was needed. And the other guy next to you was called navigator, who held the map and said, on the left, on the next traffic lights to the left. Yeah, and the driver did the instructions. So navigator in the pair programming session holds the context. He knows where to go, but he doesn't exactly know how to get there. This is the driver's task. The driver has to follow the instructions. And they rotate, they switch the roles. Yeah, not in the car, but in the pair programming sessions they do. For a while, one guy holds the keyboard and types the code in the programming language. The other one just tracks the use cases and gives the orders, and then they switch. Mob programming is an extension of this concept. You still have one driver with the same functions, but you have multiple navigators. Yeah, so it looks like a room of people sitting in one room with one keyboard and one big screen, and one person sitting at the keyboard and the mouse, and the others are in fact advising this person to write the code. And there is a timer involved. A good practice of mob programming is to switch the roles. So the driver changes every 10 minutes, 15 minutes, maybe every hour. Doesn't matter so much. So why would you do such thing? So first, what do you need? You don't need much. You probably have a meeting room like that with one big screen and a couple of chairs. You can just put the laptop there and you have a mob programming session. Or if you want to invest, then you can do what we did in one of the companies. We just designed a comfortable mob programming place with one big screen and Raspberry Pi and the wireless keyboard and mouse and a comfortable seat for the driver. So why would you want this? It's quite useful anytime when you want to learn something as a team. For example, when a new person comes to the team. Usually, especially in bigger companies, newbies spend 1 week, 2 weeks, 1 month by just reading the materials and doing some courses. It's not very, I would say, it's quite boring for them, and it's not very useful for the team. When you have a mob programming culture, these people can start participating in the mob programming sessions on the day one, essentially. You can also use it when you want to learn some new technology or new programming language, or nowadays you would like to, for example, want to learn how to code with agents, with Cloud Code, how to build an MCP. A great use case for a mob programming session, because everybody learns at the same time. Everybody can contribute with their shards of information, with their shards of knowledge, and it's immediately spread throughout the whole team. And last but not least, you can also involve non-programmers in that. I remember, where is Oneshka? We have tested that in the previous company, and an HR person was able to be involved in the mob programming session with the programming language she has never seen. Also, managers have been involved in the mob programming sessions, and they were enjoying it because they finally knew what their team did. You can expect that during the mob programming session, everybody contributes, even not non-programmers, especially if you invite some people who had some domain knowledge of the system, like testers, for example, UX designers, or some analysts. They would not be able to write code by themselves. But at the mob programming sessions, when they are navigators, they can contribute their piece of knowledge. When they are drivers, they can write code because the navigators can tell them exactly what they shall write. So they can contribute even if they are not technical experts. You can expect much higher quality of the output because even the best of us have some weaker parts. And when you have 5 or 6 people in the room, then these weaker parts will compensate, and the output is usually the union of all the outputs, quality outputs of these individuals. So what you have as an output is actually the best of the best. You can expect that the knowledge will be spreading not only about a product, but also about the small little tricks we use as programmers, as users of computers. I remember, for example, that I have learned about the virtual desktop in Windows. I have never heard about it existing, and when I was in the mobbing session for the first time, the first driver has been using virtual desktop. I said, oh, what are you doing? Ah, that's cool. So these kind of neat tricks, that this happens when you participate in the mob session with multiple people. Of course, there are some mental obstacles. Yeah? The first one is such a waste of time. 5 people writing one piece of code where one person can do it. Yeah. Of course, if coding is your bottleneck, then it is a waste of time. But the more complicated feature you do, the less coding is a bottleneck. The real bottleneck is thinking. Yeah? And at mob programming, thinking happens in one room with all the people who are involved, who have something to say, immediately available, without waiting, without rework, without back and forth. The second mental obstacle is fragility, yeah? Or better to say vulnerability. What if I will be at the driver's seat and people will know that I'm stupid? Yeah, this is a real problem. So you need to have a psychological safety in the team. It's very opening for the people to be there. So be careful with that and prepare for that. And the third mental obstacle, again from management, we already have code reviews. Why would we need more programming? Yeah, if you have code reviews, good for you, but this is just an alternative of doing code reviews. So if you do more programming, you don't need them anymore, so maybe you can save something. And furthermore, the research shows that the sooner the bug is discovered, the cheaper it is to fix it. So, and at mob programming, you fix it immediately. It's also possible to do it remotely, but I will skip it because I don't have time. So conclusion, mob programming is the fastest way I know to learn something new, and almost as a side product, you deliver high quality production code. The whole team learns at once, and by doing this, you naturally break the silos that are in the team. Of course, it has caveats. If you are interested in that, ask me. I will be still around during the break, or just connect me on LinkedIn and we can have a conversation. Thank you.
Thank you. Wow, exactly on time. All right, so Ondra, it's your turn. Let's get set up for the next presentation on not open source. Can you find the imposter open source for us?
Mirroring, right? Huh? Mirroring, right?
Right, so this talk is called, let me get the proper proper title. It's not open source, it's
Perfect.
just public code, a guide to reusable repositories. And
Very
there it
good.
is. All right, Ondra.
Thank you. Hello, everyone. How are you doing? So today I would like to talk about open source, not open source. And I would like to talk about something that you probably know, maybe little tips and tricks for you that might help you when you want your repository to be more approachable. But let's start with me. My name is Andre. I work as a developer advocate at CK Editor. Before that, I was basically managing GitHub organization for the enterprises. We had a couple of pieces on the open source part, like SDK, sample application. And throughout the time, I basically were listing up the tips and tricks, and I will tell you a couple of them. At the end, I will share the whole, let's say, knowledge base that I put together. You can fork it and use it as you want to. But before we go to the open source, first, you would probably need to decide whether you want to open source something, why you are doing it, and then you are starting to do some actions. So when you just flash out your code or the documentation or whatever you want to the GitHub, you need to decide whether you want to share it and make it better quality. You are aiming for bigger adoption. You are trying to innovate, or you are trying to add new features, or find a couple of people that have the same interest. These are the questions and these are the goals that you should start with. If you are not aiming to do those things, please, and I will show most of the showcases and the screenshots from the GitHub, because yeah, GitHub is probably number one for the open source. I know somebody is using GitLab, a Bitbucket for open sourcing, but I was using GitHub, and that's where I took the screenshots from. So if you don't want to open source these tools or resources that you put on GitHub, just turn off the features. You just go to settings, and they are listing there. So turn off the wiki, turn off the issues, turn off the pull request, and ideally start with the README. The first line is like, this is not meant to be contributed on. But if you decide to go and provide the code, repository, documentation, or the tool, and you would like to add some love to the potential contributors, potential people that you can contribute with, just go to the Insights tab, to the community standards, and you are aiming for this or this. Basically, this is the checklist that you should always have green. GitHub will help you with that. So if you don't have them filled on, there is an add button, and it will basically go through the UI and will help you to build this setup. Under the hood, it's basically just a couple of markdowns. So I will go through these in 3 groups, and then I will share the repository. First of all, start always with the README and description. The description is good for SEO, so if somebody is Googling now, AIing or whatever it's called, or searching for the topics, the description of the repository is super important, because then people can find you and you have SEO for free. You just need to put the right content there. Yeah, you iterate with AI about the content itself. Then the README. Throughout the time, I found out the golden rule of myself. This is not anything that was based on any research. This is my empirical outcome. Always start with the name, 1 or 2 sentences, or maybe a paragraph of what the tool does or what the repository is aiming for. Then a screenshot, which is not very well recommended, but I recommend it even if you don't have the UI, if you are having the CLI application. Just either screenshot the help or just put the code block with the help output, so that people know right away what is it about. Then getting started section, including prerequisites. This is always really important, the prerequisites. Sometimes the systems are different, and it will push you to even think about it when you are providing the repository. And then getting started, bullet points or lists from the user's point of view. Sometimes I see repositories where their maintainers are putting the, let's say, how to run the development environment before even showcasing what is the tool for and what it looks like. So this is the structure, and then yeah, you can put the content that is usually in the README. So code examples, links, documentations, features, contact information, and the license. And now let's go to the two, let's say, meta file groups. The first one I called Markdown meta files. It's basically these four things. Again, if you go to this insights and community standards and you don't have them checked, you have these little add buttons that will help you with the templates. So code of conduct, basically you need to set the expectation that this is the safe place for contributing. If there are some harassments, there will be contact or the way how you can report it. Again, if there are many of the templates, if you use GitHub's one, you have two options. There is default GitHub from code of command, and the second one is basically taken off from Django. So they basically took the code of conduct of Django, they make it a template, and you just fill a couple of information about you, basically the contact information if something bad happens, and it will generate the markdown, make it, name it code of conduct.md, and commit it to the root of your repository. The same is for contributing, because if you want to welcome your repository and people have no idea what they need to do to contribute, it's very hard to start with. Like if you have experience, you probably expect that there will be some kind of pull request, but there are companies or maybe you as a maintainer are expecting something more, I don't know, some spam protection where you need to, I don't know, put the password as the last word of the pull request, or sign up, or just start a repository, or whatever the maintainer would like to, or you as a maintainer would like to expect from your potential contributors or your collaborators. The third one is a license. Yeah, I think you all know what the license is. I always forget to put it, and if you don't put the license file to the GitHub, you have some default license. Honestly, I have never read the default license of the GitHub, but probably you should think of however you would like to license it. So even though it's the same, just put it there explicitly. And the last one is security policy. Of course, if you just put out the markdown with the list of your favorite restaurants and you would like to contribute to it, there is nothing really insecure to be worried about. But even if you are doing this, just state it there, like, hey, this is just for a sample, or this is just the list of my favorite recipes, or whatever. This is not meant to be used in production, or whatever. Always just put the security MD there. If you do that, you will get this nice top toolbar above the README with all of the things being listed, so people can easily get there. Again, it's good for SEO, good for approachability, and you will even get the index of the Google and now AI higher. And the second group is the GitHub meta files. It's basically the files that will be then pushed to the .github folder. There are many of them, so I just picked 2 or 3. First one is an issue template. I really like to start with 3 issue templates: a question, a feature request, and a bug. It will automatically categorize, because when people want to raise an issue, they will get this nice little selection what they want to do. Of course, there will be also a blank issue if you want, which is the default one if they have some different use case. And the last one is report security vulnerability. That will redirect you to your security MD, and that's why it's important as well. The second thing is the code owners. It's the file that automatically assigns the reviewers to the pull request based on the path of the files that people are changing. So if you are setting as a code owner of the /docs and somebody wants like to edit the docs, you are automatically assigned as the reviewer. It will save a ton of time. So if you are considering, or if you are using open source at your job, these are the things that you can use and you can reuse as well, in your workflow. But if you have your GitHub profile with bunch of repositories, you can even have them globally for all of your profile. And that's why I put together the open source guideline template, so you can scan it and you can fork it, and it basically end up with much more information than that this is. So I was just checking, probably you don't see it, but I was just checking the part of the checklist that I put together, so you can just fork it and go through it from top to bottom, and at the end you will have much more approachable repository. And if you just want to see a couple of more things, you can add the development.md, you can get the AI meta files, you can get badges. I know that these are very playful. And if you really want to have something much more broader, just go to opensource.guide, which is very excessive resource that you can read much more just directly from the GitHub itself. And that's about it. Thank you.
Thank you, Ondra. Right on time. I like these speakers. All right, next up is Miro, right there, coming up with a talk about software bills of materials, right? Think so, okay. So it's a surprise.
Oh, you ruined it. It's not surprise anymore.
So who has not heard of software bills of materials? It will be a surprise, see? Yeah, great. So these software bills of SBOMs, these SBOMs will be in Python wheels, which are these things you install on your computer or on your production environment. And somehow they will have these boxes, these SBOMs. What does that all mean? Well, we are getting ready to find out. I think those are your slides. That is your microphone and your 10 minutes, Miro.
Thank you, Peter. Hello, my name is Miro Hrončok. I am one of the maintainers of Python in Fedora Linux. I work for Red Hat, and what people somehow, I still don't understand it, pay us to do is to put some old stuff and keep it secure. That's our business model. Please do copy it. Anyway, so what happens is that customers of Red Hat or people who use some open source solutions sometimes can get a container, for example, and there is Python in it, some other software, and they expect it to be secure. Normally that means that if there is a known security vulnerability in it, they are not happy. If it's not known, they don't really care because it's security because of compliance and not because of safety, but that's another story. And there are products out there or software that can scan your stuff, your software, your stack, your container, and find something that's vulnerable because there is a known problem. And they do it by looking at certain files. For example, if they find a Python virtual environment, which we do ship in one of our containers, they can see that setup tools is in there. And in the metadata of setup tools, they can see that the version is 65.5.1, which is not really important what particular version this is. I will tell you something about this version. It's very old, and there is a known security vulnerability in it. So any security vulnerability scanner software just sees this and raises a red flag and says, insecure, insecure, your compliance is ruined, you need to do something about it. But in reality, our container has already been patched because we have setup tools that we take care of. It's really old, but we keep getting the security fixes in it. We build it as RPM packages, which is something I don't want to explain here because I only have like 7 minutes now or 8. Yeah, here, thank you. That's actually useful. There's a timer here. Okay, and we patched it, and the security vulnerability is fixed. We basically have this number in here that says this is the third build of this particular version of setup tools, and it ended up in the container. And one of the partners of Red Hat said, put that information somehow in the metadata. We need to know this. How can we tell that this is something different? What they really wanted is like, put the number 3 here. And that's not possible because this is no longer a valid version. So they would be happy, but everything else would break. So we cannot do that. So I was looking into, well, like, how do we put this information in there? And obviously, we need more metadata. So I need this, so I will put it in there. Somebody else might need something different, and then we have more and more metadata in there, and everybody is happy. I hear you laughing, and
maybe there's something to do about the pineapple, or maybe about all the metadata that will be there. This doesn't scale, and it's not discoverable at all, because like I would have to tell the people who did the request and say, okay, look at this field, and this is where you will find it. But if you are scanning something else that wasn't done by me, well then maybe look for some other field, I don't know. And I realized when I asked the Python folks, the Python upstream folks, like, how do I solve this? Where can I put this information? Somebody already solved this problem for me, I just didn't know it. And basically they were solving it for Python wheels. Nowadays, if you go and you run some, I don't know, Linux, because why would you run something else, and you do pip install some stuff, it will install packages that might have binary artifacts that have been compiled on somebody else's computer, and it will work on yours. This is done by a very complex mechanism that, why there is showing something else than me? Okay, yeah, this is showing something else. Anyway, so the idea here is that the stuff you compile also needs some stuff from the system it runs on. So they take a very old distribution, for example, CentOS Linux or CentOS Alma Linux or even RHEL, and they built the software on it. And then they took all the bits they need, and then repack it to a different wheel, and they make this wheel available to you. It's a whole complex story, but the interesting bit about this for my talk is that it has bundled software in this package that's not Pillow in this case. It's a different software. And so if I'm scanning it for some compliance, security stuff, or I even want to know what's in it, I need to inspect it and find all the metadata. So they could do the stuff I proposed, like they could just introduce new metadata field and say, we built this version of Pillow with this library in it, and we copied it inside, so let's put it into the metadata. And it still doesn't scale very well. And this is where SBOMs come in place, finally, after 5 minutes of gibberish. So software bill of materials is a standard that's designed to describe what's in the software. That's a very philosophical question, like what's in the software? Is the code in software or not? So I made an analogy that doesn't really work well, but yeah. Imagine you are getting a free pizza. You might know what's in it before you eat it. I don't know, do you just eat random free pizza people gave you? Good luck, I did. So if you are interested in what's in the pizza, you might look into the dough, see what kind of flour is in there, what kind of tomatoes are in there, where are the tomatoes from, who grew them, what kind of chemicals they put in them, and this would be some list of ingredients. Maybe if you buy frozen pizza, it's actually written there, but if you buy fresh one, it's not. I don't know why. So this is the idea, but for software. It might be a little bit abstract, but basically imagine you have some kind of file, be it the JSON file, and it explains little bits of your software. It might be multiple libraries all stuck together. It might be different things. There are actually multiple languages or specifications for this. And SBOM is not just one thing. Nobody's saying SBOM is this JSON. There are multiple competing standards, so let's make a new one, and that will finally win, I don't know. Cyclone DEX is one of them, and the idea that Python people had is that we can put SBOM files into the wheels, into the installed files, and into the metadata, and it's very simple. It allows you to put any kind of SBOM file into a dedicated directory in distinfo/SBOMs. It can be any SBOM format, and you can put whatever you want in it. There are some recommendations. You should use something that's already standardized. You shouldn't invent your own, but you can, and stuff like that. How does it look like? So for example, when we built our setup tools, and we want to tell the software security scanner folks what's in it, we populated with a BOM JSON file that says this has been built from our RPM package, and it even uses the package URL specification that's explicitly saying this is coming from Red Hat distribution, and it has this version and this tag, and the security scanners can read it. Or the other case, yeah, that's a URL. If you install Pillow now on Linux, and you look at the SBOM that's there, it's really giant, and it describes all the components that were by Auditwheel, by the tool that created this, put inside. I don't have time to go over every line, and it's a little bit verbose. By the way, the JSON is actually like 1 line long, so I had to pipe it to Python and JSON to actually see what's in it. But this allows anybody who looks into the wheel to see what's been bundled in it, or at least what's declared to be. You know, you can lie. It's just a JSON. You can write anything in there. And yeah, you can invent your own. Maybe you like your SBOM in YAML, but you should not. But the idea is whatever you want, you can put it into the SBOM folder and then inspect it. For example, if you are using some fromagère, or I don't know what's that, you can put your own SBOMs in there and describe this is built by us on this date by this tool because we can, and put it in there. I don't know why this is here. Okay, so I have 20 seconds. So let's create a virtual environment on Fedora Rawhide, which is the development version of Fedora. And let's see the JSON in there. And it already says here that it comes, the pip that I installed there is coming from the RPM package. So this already works in the development version. And that's it. You can find me on social media, preferably Mastodon. Thank you.
Thank you for all the pineapples. And that was the final talk of this batch. You know the drill. The coffee is available. The refreshments, well, find out on your own. And be back here at 14:48 for another talk. Is this still on? Miro has stickers. So please come down, sit down, and we'll see what the next one is about. So pizza talk about extra toppings. So which are your favorite toppings?
I would say cheese, maybe some pepperoni.
Cheese and pepperoni, all right. Did you get enough of them today?
Oh, pretty much. I would say even more than enough.
It's a successful event then.
Yep.
All right. Please find a seat. And please welcome Vlad, telling us about extra toppings, powering up our types. Right. Time to start. This is Vlad.
Yep. Hi all, my name is Vlad and I'm excited to be talking today about how we can add extra toppings to our Python types, specifically using typing annotated. And a brief introduction. So annotated showed up in Python 3.9, and how long ago was that, right? And since then, people have been using it in two distinct ways, I would say. One is to define some branded or semantic types in their code, and the second one is via tooling or frameworks like third-party libraries and frameworks like Fast API. Like to get the most out of annotated, the community came up with a package called annotated types, and you can think of it as a generic toolbox which you can use to define some common rules that apply to your types. And to best demonstrate how it works, I would say is by example, and I will show you how we can approach designing a very basic Python or pizza ordering app from scratch using annotated types, like layering features as we go. Let's go. Let's dive into building this app, and we'll kick the things off with the dough. That is our very basic and plain domain model, which would be basically some data classes with plain type annotations. And we have also this little small method at the bottom to add toppings to our pizza, which applies some imagined constraint which we came up with. And let's imagine we have this super complex logic to calculate total order, which will take into account our pizza toppings, discount percent, tax rate, and etc. And once our dough is ready, once we defined our domain model and some domain functions or core logic, we can add some sauce to it. That is, we can begin semantically enrich those types, and that is where we start imposing our data types constraint directly onto our basic Python types. And so let's go and add our types some character. We can transform those plain string and decimals into expressive types such as name, price, or percentage. And the key idea is that we can mix and match those annotated type primitives as long as we go. And we can use this composition to define and express more complex constraints onto our data model. So now watch this. So our domain model from plain turns to gourmet, so we add those explicit type annotations using our custom types. And we can apply the same principle to our functions as well, and making the arguments and return types more clear and explicit about what they accept and return. And all right, so once we've done that, that's time for the cheese. That is testing, and we can see how testing really binds everything together in this example. So for that we can use Polyfactory. That is one library that we can use which actually understands those annotated types, and it understands most of those. For example, it can almost automatically generate testing data for us, but it has some caveats to be aware of. For example, it doesn't really support datetime for now. It has some bugs in it, and custom string formats is also something that we would need to configure manually. yeah, but it plays very nicely with dirty equals, which you can see in here to actually write more declarative and clear tests. Another tool that we can use is hypothesis. If we want to go really bulletproof and like battle test our logic against all sorts of possible input data combinations, we can leverage things like from type or builds, which we can import from hypothesis. And from here, we can see how we could, for example, test that nobody is getting free lunch in our app. Although there are also some limitations to be aware of. For example, hypothesis doesn't quite understand nested annotations, and it has some limited support for most, like for some complex annotated types, like isfinite or timezone. Okay, so next up to the toppings. That is our database layer, and we will be using SQL Alchemy. And the cool thing is that we can actually also compose like basic tools from SQL Alchemy to overlay additional information to our types. And I like to think of it less like customization in Kubernetes, if like Kubernetes people could relate to that. So we can basically just compose those annotations into the same type, making it like independent of the core type we define. So we like still operate on the same type, but we add this extra layer of metadata to it. And so now we can really leverage SQL Alchemy's declarative mapping using those types. Like one way of doing so is via mapped as a data class tool and mapped typing utility. And as a benefit, we get fully typed and declarative ORM. And how do we know that our declarative mapping is correct? Well, one way of verifying is via running migrations or generating automatic migrations from our types and data model. And you can do this with Alembic. So the second topic is our API layer. And this is how our app actually talks to outside world. And well, sometimes like data that we consume from external systems and that we present to them differs from how we operate on the same data internally. So we can leverage Pydantics, like functional validators and serializers to once again overlay one more layer of metadata into our types. And I mean, this example is pretty basic, but feel free to check out what the Pydantic has to offer to apply more custom and specific validation serialization rules. So the concept is that using those tools, we can really create this API data flow where we bridge like our external data representation to our internal data model. And this is where like annotated really shines in modern Python tooling. So as a benefit, like frameworks like FastAPI and tooling like Pydantic automatically understand our like data types constraint, and we can always overlay one like more information, more metadata into it via providing, for example, in here some serialization aliases or titles, descriptions, and so on. And yeah, and we can verify our API via like testing once again. For example, just to see how the data is presented to end users, we can write a simple test which will validate that our reference is formatted correctly. So what's the big picture here? I mean, I would like to start with that it's not like Django and it's not like a SQL model. The key thing is, I mean, the example I showed is pretty trivial, but notice that we didn't even start to think about database like when we started modeling our data. Once we need database, we were like free to add it later the way we wanted to add it. So like I do recommend Henrik's talk on design pressure. I mean, everyone who wants to get serious about software design in Python should watch it. And that's all about like designing your data model to fit best the problem at hand, and then to be able to evolve your like infrastructure, API, your databases around your data model. And that's just something that you cannot achieve with the tools above. So that's really important that your data model becomes like the third, the first-class citizen of your application, and you start thinking about your types as well as a part of the data model, not just something to make your type checker happy. And as well as Basil, annotated doc, it's a package developed by Triangulo, an author of FastAPI, Typer, and many more. And it integrates pretty well with mkdocs via package mkdocs strings. You can go check it out. It helps generate documentation automatically from annotations on your types. And it powers documentations of Typer at FastAPI, so it speaks of something. And that would be it. Thanks a lot. You can check out this QR code. It will lead you to the examples in GitHub.
Thank you, Vad.
Thanks.
And next up we have David. There we go. All right, please get set up. And David's talk will be about polars versus pandas. So the battle of the bears. So how many of you use pandas? Whoa, that's a lot. How many of you use polars? Fewer people? I think that's pretty normal for this talk. Fewer people use polars, right? It's a bit newer.
Thanks.
I'm probably repeating something that will be in the talk already, right? Okay, so slides are almost up. Mic is up. Time is there. Okay.
Yeah.
A few more seconds.
So,
there we go. Right, David.
Hello, I'm David, and this is my talk about polars and pandas. So, if you don't use or know polars or pandas, those are both data manipulation libraries. They are both work around data frames, which is a data structure that represents a table that has named columns with different data types. So pandas is significantly older. It uses NumPy in the background, and polars is newer and uses Rust. And yeah, polars brings some advantages, that it's parallel, it supports lazy evaluation, and it's faster. Pandas is more widely supported because it's older and people are more used to it. And in this talk, I would like to focus on syntax, because I think the performance advantage of Rust gets discussed a lot. Yeah, so that's why I'm focusing on the syntax. When it comes to general differences, Pandas has a special index column, whereas in Rust all the columns are basically equal. I would say that is the main difference. Polars calls methods more, and Pandas uses square brackets for many things, and Polars things more like immutably. So let's look at how it works concretely and see that the libraries are quite similar, and migration is easy. When we load the CSV, then basically the only thing we do is we change the import. When we save to CSV, it's very similar. We change one word. When we create the data frames from a dictionary, it's the same basically. Also, we just changed one import. When we select columns, then it becomes a bit different. As I said, like polars calls method, it calls select. Pandas uses square brackets. This is how we select rows by a condition. Pandas used to do it this way and does it this way up till now. That's right. But recently, Pandas also introduced syntax that is more similar to polars. Here you can see that polars, when it filters the rows, it calls a method and it references the data frame. It doesn't specify its like full name as Pandas used to do, but since 1 month ago, since version 3.0, Pandas also supports this .call syntax. So even if you prefer Pandas, you can at least use this cool polars feature. And yeah, here is how we add a column. This looks a bit more complicated in polars. We use the with columns method that adds columns and transforms them. In Pandas, we just reference the columns and add it to another column, and this adds it to the data frame. And yeah, so here we can see that when the data frame has a longer name, then it's worth it to use the .call notation, because yeah, sorry, I was yeah, .call notation shortens the statement, and here we add columns again, like sorry. Yeah, here we use with columns, and we use the alias to add the column. Yeah, we were here, data frame is a long time. Yeah, I'm expanding on like adding column. Here, when we are adding column, the polars data frame looks more complicated, but when it's a longer name, it kind of evens out. And when we want to put the result to a new data frame, then in Pandas we have to create a copy, and yeah, that's the way how like polars thinks more immutably. And in the case where we add the result to a new variable, the polar syntax suddenly looks better, at least to me. And yeah, this is how we modify a column. This is like the Pandas way, and this is the polars way. Again, like polars calls function, and Pandas uses square brackets. And yeah, here we can see that we can easily convert the data frames. So even if you're using a library that supports just Pandas for just some part of the code, you can like switch to Pandas and then switch back to polars again. It's really simple. And yeah, here we can see how it adds up. These are the actions we performed. We are selecting some columns, we are filtering some rows, and then we are transforming a column by subtracting its mean and saving it under another name. And I would say here, when it adds up, like the polar result is more what I like. To me, this like looks clean. We just select it in one step filter with columns. The method chain looks unified. Here is sorry. Here is more straightforward one this way. Here, when I want to like replicate the method chain, I can try to do it in Pandas, but like to me, the polar way is still like more cool here. And yeah, that's it. I would like to thank Jerka for helping me polish my Pandas statements, and yeah, that's it.
Thank you, David. All right, next up, Alexandra. Is the next speaker available? It's you. Okay. So this is Alexander Mikula talking about teaching programming in a high school. So.
If you have the capability to refresh the program, you will see the change. Unfortunately, Peter is using paper notebook, so.
Well, it's more fun that way. So this is Lumir Balhar with a last-minute presentation. When is a bug a disaster? All right. So I don't think it says on the program what happened, but I guess somebody is not available. We can only guess why that is. That's also a mystery. All right, so yeah, I have nothing at all about this talk. Maybe. Okay, so they're opening display configuration, so this will probably take a minute. So let's see, what are the usual questions here I'm supposed to ask? Who of you is already using Python 3.14? Ooh, nice. 3.15, yeah, of course. What are your favorite features in 3.14? The number itself, nice. All right, next features will have to wait. Lumir is ready.
Thank you, Peter, and sorry for a last-minute change in the program, but unfortunately Alexander is sick, so he really apologized, and I'm here as a backup speaker, so I hope you will enjoy my talk as well as Alexander, and I believe he will give his sometime in the future for you. So I'm going to talk to you about when a bug is disaster. You have heard screaming Miro Hronchak in a previous talk. It's like, hey, there is a security vulnerability, we have to fix it. But what does yay mean? How bad it is? Is it really bad in my environment? And I'm going to teach you how to answer all of those questions, basically. So when you encounter a security vulnerability, you will see some numbers and some other useful information. One is CVE, which is common vulnerabilities and exposures, and that's just an identification number. Nothing really important about that. There is one example. That's pretty recent one in Python, actually. Then you have common weakness enumeration, which is more general, and it says what is the weakness in the source code that actually led to the vulnerability per se. That one here, CWE77, is improper neutralization of special elements used in command. That's a fancy name for command injection, basically. And the last piece, and the most important one for security researchers, is CVSS, and it's Common Vulnerability Scoring System. There are multiple versions of it, and I'll tell you not the latest one, but the most commonly used one. There are two components. One is a score, which is a number between 0 and 10. And 0 means, I will finish my coffee first. And 10 means, oh, we are really screwed, and the stock market is usually going down, and everything is flames, and you can imagine it. And then there is the second part, and the second part is a vector. That's the bottom part, and the bottom part looks like my cat walk around my keyboard, but I am here to explain just that part for you, so you will understand it in a minute. It consists of something called metrics, and the metrics, the individual ones, tells you the individual attribute of a security vulnerability. That means that it basically explains to you how serious the problem is, how bad the situation you are in currently actually is. So let's start with the base metrics. Those are usually immutable. Those are reported as a security vulnerability, and they usually never really change. And I will tell you some examples to know whether you are screwed or whether everything is fine. So the first thing is attack vector, which basically means where an attacker has to be in order to exploit the vulnerability. If an attacker needs a physical approach or physical access, that's the word, thank you. physical access to the system, then it's not that bad, right? The probability that somebody will walk to your server is kind of low. But on the other side, if the vulnerability is exploitable via network and via internet network, you are probably screwed. There are some things in the middle, like they need a local account, or they need to be in an adjacent network, so something which is connected to the same network as your server and stuff like that. So from one point, that's usually the green, and yes, I'm not using the fancy thing from the first presentation, so this is just a copy-pasted rectangles. So if you are on the green side, you are probably fine. If you are on the red side, not so much. Another thing, another metric is attack complexity. If it's high, that means that it's really hard to exploit that vulnerability. You need a precise timing, you need some special environment, you need some knowledge, you need some some special variable set or whatever. On the other hand, it might be low. It might require just visiting some link or sending a special crafted package somewhere. And in that case, it's not good for you. Another thing is privilege required. That tells you whether an attacker needs any special privilege to be able to exploit a vulnerability. On one side, the high means that it has to be an administrator. Let's say only administrator can do something, can click somewhere, can read some information, and stuff like that. On the other hand, in the worst case scenario, there is no privilege required, which means that anybody on the internet, for example, can go to a specific page to click somewhere to enter like invalid information into some input field and stuff like that. So that's from administrator point of view to basically no special privilege required at all. And somewhere in the middle, it's, let's say, I need at least a basic user account. That might be the low in the middle. Then we have a user interaction. You probably know that for some vulnerabilities, you don't need anything. You can just send a special crafted package. You can just visit special port. You can enter some information here and there. But for others, you need user interaction. You need user to click on some link, open some message, open PDF here and there, or send you some secrets, some code, some keys, whatever. So those are metrics telling us whether we need user to interact with us when we are exploiting a vulnerability or not. And now we are getting to metrics that are telling us how serious the impact possible is. The first one is scope. If scope is unchanged, it means that when I exploit a vulnerability, I cannot escape the scope I'm currently in. Let's say I exploit a vulnerability in the web server, and if I stay in the same web server, let's say in the same process or in the same group of processes, it's fine, and that means unchanged. But if it's if the vulnerability allows me to run commands as a root, for example, that means that I can take over the whole machine or a whole network, and etc. And that means that scope changed, and that's bad, really. Another metric from the similar category is confidentiality impact. And confidentiality means whether I, as an attacker, can read information, and probably some sensitive ones. So if it's none, means that exploiting vulnerability don't give me access to any confidential information at all. Low might mean that, okay, I can get access to some information, but those information are not confidential. And when it's high, you can probably understand what's happening, right? We are getting all the passwords and emails and bank accounts and other stuff like that. That's confidentiality, telling us whether we can read something which is confidential. Then we have integrity, which has similar meaning, but in a sense of changing the data. So none means we cannot really write anything anywhere. In low, we can change something, but it's not a big problem. Let's say, imagine a kiosk computer somewhere in the train station. If you change something like background there and it's redeployed every hour, okay, who cares? Right? But then when you imagine a bank account and you are changing balances of individual accounts, that's a problem. And the third metric from the same category is availability. Whether you can change, or you can, let's say, switch off the server, or you can fill the queue in the service so much that it's gonna be unavailable for everybody else. That that's what's usually happen. Even if you don't have access to critical data, even if you cannot change them, you can still make the service unavailable for others. That's what's hidden in the shortcut denial of service attacks. You know them probably. So those are the base metrics. Those are one set, and those are usually stays unchanged. Then we have temporal score metrics. Those might be either undefined sometimes or evolve in time. First one is exploit code maturity, which means whether the program that can exploit the vulnerability, how mature it is, whether even a person without any programming knowledge can use it, which means on the right side the high thing, because some exploits are just served as packages in Metasploit and old or Kali Linux and other distributions like that, which basically means that anybody without any particular knowledge can install the exploit and start pointing to some servers whether they are vulnerable or not, and can just send the packages and see what happens. That's on the high side. When it's unproven, it might be only theoretical. It might be only in a way that, okay, if it's noon, it's a March, our RAM is 90% full, and we send this package somewhere, something might happen. Theoretically in my work, but nobody really ever exploited that vulnerability. And we have something in the middle, proof of concept, which might mean that it happened somewhere in the laboratory, or that it's functional, but it's not that weaponized already. So there is a code that I can run, that I can point to the server, but it's not a problem yet. So we have a code on one side that can exploit the vulnerability, and we have a code on the other side that might solve the problem for us, and that's remediation level. On the green, it means that the official fix exists. So all you need to know and all you need to do is just update your server, install the latest update, and you are fine. That's a good part. And actually, some of the vulnerabilities that allowed attackers to take over control of your server in the past, like a Heartbleed, if you recall that, attackers used that to take over control of your server, install updates, and reboot that server for you. So basically, some smart people are going over the internet, installing updates on all the servers and fixing them, basically. That it's possible if a fix already exists and you can install it, ideally in an official way. Temporary fix might mean that there is a patch, but it's not released yet outside. So you might need to apply the patch on your own. That might work as well if you are a skilled software engineer enough. Or there might be a workaround. That might mean that you have to turn off some of the plugins, close some of the ports, limit the functionalities of your solution or whatever. Or the worst case scenario, it's not available at all. There is no protection. You have to disconnect the server from the internet and you have to turn it off. That might be also a workaround. And then there is a report confidence, and that tells you how trustworthy is the report per se. The confirmed means that usually the vendor, which is the one producing the code or shipping the component, saying, yes, it's true, the vulnerability is there, we have a big problem now. In the middle somewhere, it's reasonable, which means that the report came from some security researcher with a good credit, some good history of previous reports and stuff like that, or it might be completely unknown. And sometimes, and nowadays, especially in the era of AI, we have that a lot because people are trying to use AI. Hey, this is a pile of code. Try to find a security vulnerability and stuff like that. And they are without any back checking. They are just reporting that and assigning CVE numbers. And the upstream developers of those software usually, oh, it's not a vulnerability. It's a feature. It's this and that. And there are a lot of arguments about it. So if the report is unknown from an unknown source, it might be good for you because it might mean that it's not really a problem yet. So now you can read the vector. So I have two examples for you. One is really bad and one is not so much, to give you really the real example how it might look like. So in one example, when it's really bad, you can see from the score, which is 9.7, it's critical vulnerability, and it's remote code execution in a web server, which means that if you use some request parser and you cause some heap overflow, which is a memory problem, an unauthenticated user can run a code as a root. And the exploit is reliable, and it's widely weaponized, which means that we have a code that we can use to use that exploit and stuff like that. And when you take a look at the vector on the bottom right now it makes sense, right? The ACTAD vector is a network, which is a problem, really big one. Attack complexity is low. There is no privileges required. There is no user interaction required. And because we can run the commands as a root, that means that the scope is changed, the confidentiality problem is high, integrity problem is high, availability problem is high, and so on and so forth. And that calculated together is 9.7 and a big problem. Another one also can be considered as a security vulnerability is some leak of non-sensitive data. Let's say that the local user on your system can read a temporary file which is created by privileged service, should be in a way that it's not readable by anybody else, but stuff might happen. It's a temporary file, but there is no sensitive data in it, just the process number and some command line arguments, nothing really secret, but it's there. All right, this total score is 2.1. Calculated. You can use an online service to calculate that, and you can see that the attack vector is local, which means that we need a local account to actually use that vulnerability to read the process data, right? Attack complexity is high, is temporary file, which means that it requires some precise timing to be able to read it. There are some privileges required already because we need the local account of that machine. There is no user interaction required. Scope is unchanged because it doesn't allow us to access anything outside, and so on and so forth. Thank you for your attention.
So that was our backup speaker and organizer, Lumir. And next up, Shimon. Is that the way to pronounce your name? Oh, almost, okay. Well, this fine gentleman will be speaking about the Postgres database, stopping to use some indexes. So please get set up, and we can continue with the 3.14 features. Do you remember what that was about? So there was the number itself, 3.14. And remote debugging, is that correct? Who said that again?
Let's wait.
Nobody. Who is using remote debugging in Python 3.14?
Cool.
2 people. Okay.
Yes, okay.
So. Who has used it? Who has heard about it? 3 people. Well, maybe there might be a talk about it next time. Right, stage is yours.
Cool. Hi, my name is Szymon, and today we will solve together a PostgreSQL mystery. But first, what does PostgreSQL have to do with Python? Well, some of us maybe use ORMs, but it's just a tip of an iceberg, because under ORMs we have SQL and many other features, but today we'll only focus on the execution plan. So this mystery started on Monday, happy Monday for every developer, and everything was fine till someone decided to do the deployment. And then it was found. It was found dead on production. So what happened? Exhibit A, the timeline. At the beginning, everything works. Then we have database migration. Everything still works, but slower. So exhibit B, the query. So we had a users table and events table. Basically, one user could have multiple events, and we could have a join between these 2 tables. And additionally, we filter by some users, score and event category. That's the basic we need to know for the scope of the presentation. What happened? So the deployment was just a simple data migration. It's a Python conference, so here you have some Python, the only Python on slides. So basically it was migrating some events categories from in progress to 3 others, with majority being failed. So first suspects by Captain Obvious, aka Google and ChatGPT, whatever you put about slow queries, you get something like you don't have indexes, but it wasn't our case. You have outdated statistics, so run analyze on your database to update them, but it was still slow. And your query is optimal, but yeah, let's keep it because it worked before. And few others. And for those who didn't notice, this one is nano-banant Captain Obvious. So all these theories checked out, and even our junior developers didn't know what to do next. But there was something else. After analyzing, explain, analyze, we noticed that some index was not used on the events table. So it wasn't possible to query events table efficiently. So there was a sequential scan on the events table. So why Postgres decided to go with sequential scan? And to do that, to explain that, we need to see Exhibit C, which is PostgreSQL notebook with statistics. Postgres stores some data about our columns. So we have, for example, number of distinct values in a column. In this case, does it work? Ooh. Yeah. In the users table, the score column, we have 900 distinct values. It also stores information about most common values in that column, along with their frequencies. So in our case, we have value 2, which is much more common than value 1. So how Postgres uses these values to estimate number of rows? For most common values, it's pretty simple. It finds a row in pgstats view that corresponds to the column by which we filter, and it checks if the value by which we filter is in the most common values array. Then it finds the most common frequency that corresponds to that value and uses this in the simple equation done. But for values that are not in the most common array, so Postgres does not know how often this value occurs in a column. It uses it assumes uniform distribution. So basically it divides probability of finding non-most common value by number of distinct values that are not most common. So uniform distribution. And this may lead to estimation errors, which we can see on the second page of the victim's notebook. So that's basically what Postgres kind of stores. The red line, this is the distribution of user scores in the users table. So red line indicates maximum value that is in the most common values array. The orange line is the edge score for which the estimate is the most accurate. And the green horizontal line basically indicates how Postgres sees our data. So blue beans are the real data, and green line is how Postgres assumes it is. And these 3 areas, the green one, if we filter by a score that is in the green area, Postgres gets accurate estimate. For the red area, it underestimates, and for the orange one, overestimates. And to better understand what happened, let's see these 2 queries. The first one, before the migration, was filtering by category number 1, which this category occurred only in 1% of rows. So in that case, Postgres used nested loop with index scan on events table and users table. This was pretty fast, 2 milliseconds. But after the migration, with category equals 2, it somehow switched to hash join with sequential scan on the events table, which was 5 million of rows, and hash join the users table. And it was much, much slower. So to recap, query A, before data migration, it was fast because of the index scan. After the migration, query B sequential scan on the events table. That's important part. So this brings us to the real question. Why Query Planner, why Postgres decided to use sequential scan? And the root cause was the score column estimation. In our case, it estimated over 7,000 of rows, but the actual value was 5,000 and a half. And this 30% error was enough for Postgres to think that it's better to scan 5 million of rows instead of probing the index. And the temporary solution was to disable sequential scans off. So it just encourages Planner to not use sequential scan. It doesn't disable them entirely. So now we knew that query can use index, and the correct index is in place, and the query is faster. So the assumption was that we have correct indexes and can be used. We just need to figure out why they are not used. And a few hours later, we found out a true fix, which was increasing the statistics target on the score column of the users table. And why users? Because of this overestimation that Postgres done, it assumed that it's better to switch to sequential scan of events table and join users one by one via hash join. So after increasing it, Postgres now could track most common values, this array of most common values, and estimates for rare values were much more accurate. Yeah, in our case, it was just 800 difference. So that's how it looked before the fix, and that's how it looked after the fix. So the green area is much more wider, and because of that, all these scores from 0 to 600 something estimates for this filter is much more accurate. And you can see that this green horizontal line at the bottom much better represents the true distribution of a data. So by changing the statistics target, you basically configure how much data Postgres knows about and stores statistics about. But at the cost of the performance. Okay, so after increasing statistics to 500, Postgres again switched for the query B to nested loop with 2 index scans. Bam, case closed. So how to prevent such a crime in the future? One thing is to reanalyze tables after major migrations. If you change the distribution of a data, it's better to do it so Postgres can better estimate what plan to choose when executing your query. Second thing is to set statistics target according to your table. For many cases, it's not needed because default value of 100 is just enough. Or if you have really uniformly distributed data in your column, then it's not required. And you may want to use extended statistics, which is basically correlating statistic between 2 columns, for example, country and the city. And the last one, Postgres also stores info about how many times your index was used versus sequential scan. So we can use this data to check if the plans are good enough. Thank you.
Thank you.
Almost. No.
Very good. All right. Thank you for the talk. And next up we have Hansa here. Or yes, it is you. So you are supposed to talk about turning functions into command line applications. So please get set up. And we'll continue. So the features we came up with were not very popular, so does anybody have any other feature they like? No, this is boring. Okay.
Okay.
Anything from 315 from the fans over there? Yes.
That's cool.
Sampling profiler.
Like
Not
that?
lazy imports.
That's cool. They are cool.
Okay, Honza, bash it.
Okay. Welcome everyone. I'm Jan, and this is an experiment, and at the same time, relatively beginner's topic. Is it possible to turn like a function that you or your colleague created and take 10 minutes to turn them into a CLI app? Well, if you have just 2 minutes, you do this. And actually I tried, and it probably created better code and maybe even a better presentation than I did. But I mean, we're still human, so I try to do it normally. So let's say that I have some function that I developed in my free time, and let it be a function that downloads the meteorological forecast from the Aladdin service and just turns it to a data frame, and then, I don't know, I just played with it in an IPython notebook or something. And now I would like to distribute it and make it available for people that don't have IPython notebooks, they don't want to install Python, they just are lazy or just like living in a different field than us programmers. So what, I mean, this function is nice, so let's play with it. I mean, it has some dependencies, but I have an executable called SumPython that's somehow magically has everything properly installed. So if I call it and I do from import star, I have some functions that I can use. So as everyone knows, Ostrava has the ID of 321. And if I call it, I just can immediately download Aladdin forecast for Ostrava. There are some other places which I don't have the names, don't remember it, but I mean, you can download others. But that's not the point. It's a function and it works, and that is important. So if, on the other hand, I'm like just installed my computer, someone sent me the script, I do this, and I'm basically stuck because it doesn't work. I don't know what module is, I don't know what HTTPX is, and even trace back what that is. So it's fine. Now we should do some work before, like, we send it to our grandma or whoever. So first, there must be a way how to assure that the user has all the dependencies. Second, I mean, if I have a function, I mean, how to call a function from a CLI, then probably I should take some care about it. I need to take the arguments from the command line, and I need to display the data somewhat. And then, of course, the last but not least, find a proper distribution channel and send it via that channel. In order to like describe what dependencies I have and also to solve some other things that I need to create a Python package. I will use a UV tool for that. I don't have time to go to the website or whatever. It's just like a magical tool that does packaging, project management, and lots of other things. It's very new, so like this trick would not work 3 years ago, etc. And also, you don't have to actually create a package, but that's I don't want to take this shortcut because that's not for now. So I will use UV, and I will create a package which in itself is nothing but a directory structure that has some code and also some metadata. And this metadata is stored in a PyProject TOML, which already contains the almost every information I need. Unfortunately, it still doesn't contain the dependencies, and also in this talk, unlike Karolina's, we care about licenses. It doesn't contain license, but for simplicity, I will not edit it now because I have it stored and it will appear magically afterwards. And so, like, first thing, I need to specify the dependency, so I just add them. Somehow the UV tool did that very magically. And now I see it in my PyProject TOML file, which is cool. And so it also created this dot underscore blah 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 init.py file in my chmix directory, and it contains a main function. It's called main. And if you look in the PyProject TOML, you see that in the section of project scripts, it contains something like a definition of an executable. So I will know that in this file I will have this main function. I don't have to understand it deeply, but if I override this function with something, I'll be happy and it will run. But and if I run it, so I can really run it, I hope. So if I run, it should. Okay, never mind. It doesn't work this, but that wasn't. I didn't want to actually show that. So now I want to create a nice executable from that. And so I will copy my code to the new file, which is boring, so I will not show it how to copy a file. And I will just edit it so that it will start working as a CLI app. For that, I will use a tool called Typer, which is a library that allows you to add decorators to your functions. Nothing but decorators, and then everything will automatically start happening. You don't have to read the documentation for argparse or some other magical library. So Typer is very, very simple and easy to use, especially if you are into type annotations and the annotated annotations and etc. So I will add the Typer, and it is there. So now I have the file, and this will be the only live coding I will do. So edit time. So I will import Typer. That's one thing I need to write. I need to create some sort of app. I will need to call it main because I know that the function has to be called main. So I do Typer parentheses, and then decorate two functions I have. So I will have main.command. This will allow this to be a function, and also the list of location, let's say, so that I have at least two commands so that I have some fun. Okay. I hope that is correct. I don't want to return back here. Okay. And now if I run just like the usual --help, what is that? Okay, yeah. So now that's what I got output. So currently I have like CLI that automatically tells me what it needs, and I can play with it. I can run. So if I do that, now I hope it will work, because otherwise, so Cmax login and the magical number. Okay, yeah, it does not print. That's the problem. That's another problem. So what I have to edit something else. I also don't just need to return the thing, but I need to print it. There is not much time for us to create any sophisticated, nice lines, but it would take, I don't know, a few extra minutes, which we don't have. So now if I go here, and okay, I do again, and I do this, I have this. Okay, so let's say that's like that passes for a user interface. It's almost fine. In the thing that we will upload, it is a bit more better. And now, okay, but live coding has its limits, so I just randomly retrieve the thing that I want to have. So and now this should be up to date. My file contains a bit more lines, but not many. We don't print it, we convert it to Markdown first, etc. But apart from that, everything is fine. So now then the last thing, for which we have 1.5 minutes, we need to get it to someone else's computer. We have the package, that is fine, and we would like to upload it to PyPI. It's very difficult to set up your account in 5 minutes, so you need to register for an account, get some two-factor authentication ready. You need to create a publish token, then somehow pass that token to your package manager or build system. You don't have time for that, so I'm skipping over this. But once you're done, that's like once for you for each user. Then you don't have to do anything. So you just first build the package, done. You publish the package, done. I mean, it says failed because I already did it before, and I'm uploading the same version. But let's say if the version is not there, it would still work. And I don't have an extra computer with me, so I just run it in a Docker. and so completely different computer. So now the UVX tool is a thing that's also part of UV that allows you to download something from PyPI and run it. So CMRX, Aladdin, and it's even more clever because, okay, and now I do this, and I get this, and it's on a completely different computer. And with that, I'm done, and thank you.
Thank you very much. And that was the last talk of this segment. So feel free to have some more drinks, maybe some more refreshments, and we'll meet back here on the hour. Please don't be late. Please find a seat. Please tell your friend to find a seat. We are almost ready for the next talk. I hear it will be quite excellent. Right, I think we need to get the speaker talking to get you to sit down, Ryan. All right, sound levels are down. I think this is the time to do it. This is Vladia and his talk about OpenPixel.
Hello guys, as you know, Excel has been one of the widely used tools in corporate environment for decades. Whatever we're talking about, management, finance, analysts, and even most common workers or some common workers use Excel to fill some product sheets, stock inventory, and so on. Companies often have a lot of tools, some internal tools, ERP, CRMs, production control, inventory control, inventory management, and this is the place when integration comes into play, and Excel is one of the tools widely used as a place where data are exported, imported, and different checks are made, data validation, and so on. The first version of OpenPixel came from PHP, so something good from PHP, and it slowly evolved from since 2014. It was to 2019. It was for older version Python, up to 2.7, up to 3.5, and from since 2019, version 3 is available, and it still evolves slowly. You can use it now. It's very easy with modern Python. Let me show you some very basic example how to make export. As you can see, it's very short script, only 6 lines. If you have data ready, I have here some fake row, but what you do, you just prepare new class with workbook, then with worksheet, and you go row by row and append it to the Excel sheet. If you have data exported from another company system like ERP, for example, price list, production, inventory, what do you want? Just use simple loop, join it one by one, and you are ready to provide this data to your colleagues, to management, to someone who needs it, even external partners, if you want. Yeah, your boss probably will love these fancy fonts, vivid colors, properly aligned values. So you can use a lot of different classes to set the different styles of your cells, columns, or rows. You can use formulas, but remember there is no no implementation of calculations. So if you use formula, I mean valid formula, it is stored in the file, and it is not calculated, it's only stored. When you open it in Excel or another desktop Office application, you will recalculate the values. And if you make a mistake, you will see error in open source Office, or this kind of error in through Excel. It can be helpful to use some special functions to recalculate the position. You can use standard Excel A1 notation to address cell. So, for example, B3, as we have on the example, means second column, row number 3. You can translate it to index and or vice versa. You can use those utilities from OpenPy Excel utils. For data reading, it's even shorter. You just do the same loop. This loop is reading data row by row, and I'm printing it out, as you can see in the output down. Please notice formulas are not calculated in this example, but if you want calculated results, you can use a special parameter data underscore only is true or is equal to true. Then you will get calculated values. As I said, if you will read file generated by OpenPyXL, you will not get calculated data, and you should never trust those calculated values, because it can be tampered or not calculated at all, because users can disable the calculations in the Excel itself. The important thing is OpenPyXL does type conversion for you. You don't need to care so much. Just pass string, number, float, integer, float, or time, and it will be properly stored in the Excel. And if you read it, if it's there, you will read it properly. You can see most of them are properly recognized type, or at least similar type you need. Security. This is way, or this OpenPyXL can make for you a perfectly valid Excel file, but you can create a combination of object or unexpected combination of objects, and it will be not properly displayed or recognized by Excel or other application. So here is one example. As you can see, overlapped merged cells. You can create it. There is this creates a valid Excel file, but it will be not properly processed by Excel. It will make some. It can lead to some unexpected issues, maybe even security breaches. There is another thing about security. As you can see, or you can understand, by default, OpenPyXL use LXML as a library for XML processing, and as you know, XML can contain external references and entity expansion, and it can be risky. So OpenPixel has an option to use a diffused XML library instead of LXML, and then everything is much safer. It neutralize this dangerous XML features. It blocks, as I said, entity extension, external entities, and other attack vectors. If you use this construction, you can be sure every time the right library, XML library is used, and you are safe, or at least safer.
Thank you, Vladia. Do we have the next speaker? Is anybody coming to the stage? So there's Victor. Or Vicky. Hello. So this one will be about Python on the edge. Please put the laptop on the table, not on the edge. It doesn't fall down. Yeah. Living on the edge. All right. What do you think this talk is about? Python on the edge. About edge computing. So who knows what edge computing is? 3 people. Ah, this will be a very enlightening talk then. All right. Are you ready?
Yeah. Is there a presenter here?
All right. That's Vicky.
Does it work? Hey. Will it blunt? Or no? Oh, okay, whatever. Never mind. So, hey everyone, I'm Vicky, and today I'll be speaking about Python on the edge. I'm usually doing the technical stuff and experimental AI research. So I was about to deploy some like Python server, and then I realized like let's be honest to each other. Like deploying Python API on VPS is, well, not a trivial operation, even with the cloud code or codecs. It's still bad. Like you suddenly manage the OS, you need to patch it, you need to run like apt, you need to dependent spinning. Observability, well, you can do print, but, well, it isn't the best thing. And suddenly when your app becomes a hit overnight, well, the VPS crashes and you can cry. So I just want to have fun, want to play with Python, so I need to find another way around. And that's why I came to do basically serverless or edge. And then I realized like edge and serverless is not the one thing. You have like multiple flavors. And basically you can run your Python on the edge. You can run it as a serverless or like as a CDN triggered compute. So we'll explain each other. So in the end of the day, you have 3 paths. You can choose AWS, you can use Cloudflare, or you can use Vercel. Like that's what you have. Or still you can go back to your VPS or run it on the Mac. Still works. So the standard path, usually that's what many people usually choose, is like AWS. You have Python, as you know. It runs well. API works. It's great. If you already know AWS, you don't need to reinvent the wheel. Basically, the tools are there. The bad is, if you are new in the AWS, you need to learn what the cloud for on this is like CDN. You need to learn how to properly write the Lambda. Then the CDN does a lot of caching, and then you have Lambda Edge, which is basically Lambda that lives on the cloud front, and that becomes super confusing. And additionally, you pay for egress, so your bill can be like up to 75K, which is not perfect. And then you basically have another alternative by Cloudflare, which is kind of nice. Everything runs in isolate, very close to your user, so it doesn't matter where your user is located, is found next, as close as you can get. Great for low latency APIs. I already served like 4 terabytes of data through the Cloudflare. It works, it's seamless. The perfect is that runtime is reused, so anytime you spawn basically like these small instances, they are reused, so there is basically no cold start, and you pay only for the CPU time, so anytime you are waiting for some external HTTP request or your key value database, it isn't counted towards your like CPU time, so it's perfect. On the other hand, CPU budget is strict, so any heavy computation should be avoided, and it can consume up to 128 megabytes, which is not a lot. And the biggest problem is that basically it's like CPython compiled to WASM, which is like, well, you will see. And there is the like third hybrid approach on the Vercel. It's not true edge, it's like serverless, but they claim to have like serverless ergonomics with their like concurrency model. You also pay just for the active CPU time. It's very good if you need to like have API routes with the full stack framework such as like FastAPI, Jinja, which was mentioned. It's super cool. It's very flexible, so you can basically run Python, Rust, whatever you want. Bring your own language. It reuses also warm instances, so it's almost instant, and it's very good for AI workloads, which I've used before. And so can you show us something except talking? Yeah, so I got actually like task to deliver like static analysis report, and I was like, okay, that's kind of trivial. You run the tool, you get some output. It's usually like Sarif, it's like static analysis format. It's a common standard. So it's like, okay, my task is done there. I sent the mail and I got a reply, but we need PDF. And I'm like, okay, sounds like a fun. And then I realized the tool that I used enables you to have like PDF report in the enterprise version. But when you are a person like one person startup, you are not the enterprise. So what we can do with it? So basically, I took a Python and wrote a small tool for that. Basically, it's Sarif to PDF. And how does it work? It's basically like fast API, which is running on the Vercel. There is like Jinja template, so basically I just upload the file, get the PDF back, and it works. And then I was thinking yesterday like, but can it run like truly on the edge? And the thing is, yes, it can. And I managed to create a version on the Cloudflare, which was kind of nice. Render in sub-millisecond is also globally accessible, but the development process was so slow and painful that I wanted to cry. And the best thing, like I wanted to buy Ozempic for the code because it has like 22 megabytes, and imagine to serve 22 megabytes to your user. The standard is up to megabyte, not 22. So I managed to do that, and it was fun. And so your question could be like, why should you bother then? Well, I was able to go from develop the idea to production in a matter of minutes. In the case of Vercel, I just like made it and then send the PDF. That's the PDF report actually. If you have some other things in your environment, such as like S3, R2 on Cloudflare, or your Redis on the Vercel, it works out of the box, so you don't need to reinvent your own wheel. You don't need to reinvent how to connect like S3 to some other thing, or trying to use some other secure systems. So, and you skip basically setting up the chunky server. Like VPS is fun, but in most cases you don't need it. Just ship and have fun, and yeah, it costs fraction of the cents, except the AWS. And yeah, so this was like a case of personal software. I just needed for one thing, coded in minutes, and was done. And TLDR, what to choose? Like, if you need something very simple, very seamless, just go for Cloudflare. Except the development, everything was kind of okay. It was fast. Plus, I have like a lot of other services such as like images, R2, key value storage on Cloudflare. So everything works well together basically, and it was fun. For anything else, I would recommend Vercel. The compute could be a bit more pricey, but the like development experience is like ultra great. Just try it. It's worth to like spawn some project. And AWS is good, especially if you have like experience with that. Otherwise, just go to Vercel. And yeah, this is what I should pick. And yeah, Bernie is asking you when you will run your Python next time. So if you have any questions, feel free to join me, and let's connect on LinkedIn. Thank you.
Thank you, Vicky. Come on. Right, next up, Vasek. Yes, my notes are correct this time. My cache is valid. So Vasek used to be a senior developer, then became a vibe coder, and then came back, according to the title of the talk.
Okay.
Do you actually stop being a senior developer when you become a vibe coder?
Just try it.
Yes, you do. Ah, so who thinks you do?
Yes, it works. Perfect.
4 people.
Okay.
Okay.
Okay, thanks.
Let's see your opinion, Vasek.
So, hi, I'm Vasek, and today I'm going to tell you my last year in a nutshell. But don't worry, I avoid like my tragical dates. I will just stay with AI-driven development. First of all, I was never like an AI hater, but roughly a year ago, there was a lot of tweets or posts from AI companies or AI enthusiasts that the normal development or normal coders would extinct. I was very skeptical back then, but then I realized something. 8 years ago, I was replaced by myself. What I mean, I automated my job so well that I basically fired myself. And I was thinking, could this happen again? And if it could happen again, I would like to be in control of that process. So I decided to not wait for tools to get better and try what was on the market. Back then, I was trying to do some, let's say, artisanal code. Every comment, every docstring had a purpose. I tried to play with names. I wanted to use abstractions everywhere, well, where it was needed. But the problem was when I want to make some change in the project, because if you, let's say I was using a Copilot from the start, and Copilot for me was always like a copy-paste on steroids. And if you want to make a change in some big project, you have to do changes in the database, backend, frontend, tests, and then update the documentation. So you do 3 days of grind just to see the alpha version of your result. And what I was trying was all the tools on the market, and I felt like I was babysitting like a very educated nerd child. But let's do a quick detour, because
maybe if you know the company Windsurf or try its agent, like there was an issue in the summer when Google acquired like a whole development of this company, and what was left is this ghost ship with just a salesperson on the deck. But back to the development. Let's say with when I was using the agents you saw before, I tried to use LLMs like Sonnet 3.7 or newer at the time, and it looked like this. It was like a nice hotel. As a code, it looks senior. There were clear names. It used right libraries and syntax until you open the first door or the first component. Well, the business case was solved somehow. What I see is broken core business logic and very big inconsistency if you compare the, let's say, first look of the hotel and the, well, the main purpose, and that's the rooms. And what more, with these agents, you are trying to do a fix of a fix and always try again. It does fallbacks, sometimes fallbacks to nowhere, because the logic wasn't there already. And what I try to push these agents to the limits. I was challenging them with a task, and I was becoming quite good prompt engineer. But another change happened, and that was when I tried Claude Code. Well, if you don't know, people here in Ostrava talk in very short, strict way, and I realized that I can talk in Ostrava slang with Claude Code, well, model opus at least, and it actually understands me better than my boss in Prague. But let's do a bit fast forward today, and I would like to do a coming out. This is the amount of the code I've typed by my hands this year, since the start. Does it make me vibe coder? Well, it's a little bit complicated, because if you imagine a typical vibe coder who just give a prompt, well, it then decides, well, it works, and then he pushes it to prod, it could break at Friday night, and you end up with debugging whole weekend. First, well, the first advantage of this approach is a speed, but if you are talking about speed, let's compare it with a car race. This is probably the best car you can buy on a license plate. It has very sophisticated technology, but it's still a tool. Without proper driver or developer in our case, it's still just a tool. And on the other hand, we have the AI haters who I respect them, but on the other hand, they are using old school technology I cannot use. If I should wear one of these cars, I would probably crash, but probably not even that, because I wouldn't just start it. And Then we have the third category, and that's the typical wipe coder. I call him a lazy developer. And sometimes it works. If it crashes, okay for you, at least. But what it really can create is a technical debt. If you don't know how your code works, you are neglecting it, but you have to remember that not OpenAI, not Anthropic, they are not responsible for output you push. And for me, it means a new era of development. Don't be afraid to use best technology at the time, which is right now Cloud Code for me, but that could change in a few months. Use the fact you don't have to type code manually as your advantage. Because you can experiment, you can prototype, and it's much faster than before. And if you are more juniorish, I also have one tip for you. Never commit and push what LLM creates. Ask why did you use this library? Why you didn't use that library? And always, my favorite, ask for alternatives. I'm trying to be like a nerd who is asking everything. And the best part is the AI doesn't care if I want to refactor the whole project 10 times. It just do that happily. And what I mean by back again from wipe coder to senior developer, I mean it's not about the way of how the code is created anymore. You can type it on by your hand, you can copy it from ChatGPT, you can use Cloud Code or every other tool. You can use, for example, another programmer. But it's about meaning. You have to understand it, and you have to understand it much more than before, because if the way of typing is not so important, what will be the next? And one last thing, always stay in safe environment. Thank you.
Thank you, Vacek. And last but not least, we have Honza Král. Please get set up. So this talk will be about searching, not scanning. Does anybody have any idea what that's about? You know, you have inside information.
Yep.
Yesterday at the beers, that's the best way to get information. Yes.
Yeah.
Doesn't scale as much as a live stream conference, though. Yeah, so apparently this is about databases, probably?
It is.
Full text search. There. Now I have inside information here.
Yes.
Are you ready?
I am.
Okay, Honza.
Hello. How is everybody's day so far? Still have some capacity to absorb one extra talk, just 10 minutes, it will be short. Though, previously I gave this as a full talk for 45 minutes, so we're going to speedrun this thing. So this is about like searching and essentially what a full text is.
because we are all familiar with all kinds of different databases and how you query them, and they have different quirks and features. So this one is, how does full text search differ from that, and what is kind of the minimum that you need to know to understand how to approach that problem. It's not specific to any particular technology. It will work the same with Elastic as it will with Postgres, T-Search, or anything in between. So first comes my favorite question for everybody. Have you ever read a book? Awesome, awesome. I would be worried if more people didn't raise their hand. So this is what it's called, an index. This is where the word comes from, and this is a very old data structure. It dates hundreds of years back, where we first kind of started saying, okay, we have a big book, we need to understand where to find different things in there. And so we came up with this. And it's a list of words, and for each word we have a list of pages. That's simple. And you can use it because the list of words is sorted alphabetically, and the list of pages is sorted as well. So that way you can easily find what you're looking for. And that's literally the same that what we're going to do now. So let's actually build it in Python. Like, let's build a very, very simplified toy model, and then let's see what is missing and what is kind of required to add more. So let's start with a function. We want to create index with some document. So we have a bunch of texts, a bunch of strings. And we want to create an index so that we can then later perform a search. A sophisticated, hopefully fast. We'll see how that works. So we would usually use a sorted list and a sorted list, etc. But because it needs to fit on a slide, and because we have Python, which is a high-level language, we can use a dictionary and a set instead, because it will fit better with the types of operations that we want to run, which is primarily merging lists or sets. So this works just fine for us. So we just instantiate a default dict, and we have just one index here. We could just as well have a dictionary of these for each, if we have documents with multiple fields, etc. And then we just iterate through our documents. We take the position in the initial list as the document ID, because again, fitting on a slide, and we just add those document IDs to the items in the index at the end of the page, and that's it. So that's how we build the index, super simply. So how does the search look like now? I get the index and I have a query. So first I need to identify all of the different lists of pages that I want to look at. So I take my query, I split it into words, and for each one of those words I locate the list of pages, in my case the sets, which is why specifically I chose to use a set, because I can just use an intersection to find out what are the pages that contain all of the words that I'm looking for. So this is an implementation of an end search, where I need all of my words in my query to be present in the document. I will give you two guesses what I would have to change to make it an OR search. I just put in a union instead of an intersection, but the rest remains the same. I couldn't even do more fanciful stuff, which says, okay, at least two of these words needs to be on the page for me to consider it a good result. So this is essentially how full text search works. This is the only thing that you have to understand. And now we're going to go over the things that we've done wrong, that we've cut the corners, and figure out how we can do it better to enable more features. So first, the most important one is just splitting the text is not enough. If you've ever opened a book, again, you probably haven't seen 10 different entries in the index for running, run, runs, ran. No, it's normalized. And also, you wouldn't probably see all the different capitalizations, a run with a capital R, with a lowercase, etc., etc. So we need to normalize the text. That's a process that's called analysis, and it literally does this. It does what we implemented with just the split, but it gets a little more complicated when you think about it a little bit. Like O'Connor, like that is a name of a person, but do we split on the apostrophe? Does it differ in different languages? Is it Connor and Connors, as in a possessive? Do we split on that, or do we not? What about languages that don't even use Latin alphabet? What do we do there? There are languages out there that don't even use white spaces to differentiate their words. We need to be able to split those. So that's just when it comes to splitting. Then we need to kind of do the technical normalization. So that's what I mentioned. Yeah, we want to do lowercase everything or uppercase, doesn't matter, but consensus is it's lowercase just looks better. We also want to do something like ASCII folding. My name is Král, I have an acute on top of the A. I never type it myself. I'm not sure I even know how to turn on a Czech keyboard on my computer. I always just type it lowercase Král. And so if I didn't have the ASCII folding in my search index, I would not be able to, find myself. That would actually explain a lot. Those are some of the technical aspects that we need to account for. Then there are the language aspects as well. So things like stemming, that's your running versus run. And in some cases, it's easy, and actually like one of the most common used tool for this, it's called a Porter stemmer, and it's literally just a sort of 5 rules. If it ends with ing, you remove the ing. If it is preceded by double letters, make it only a single letter, etc. And it works for English surprisingly well. For Czech, no. So you have to have different approaches to it, and those are, by definition, very, very language specific. I'm not going to go into details. You can Google yourself, and we're slowly running out of time. And there's also a lot more to this process. You can have synonyms. You can say, okay, run and trot and jog and all of these different words are really a synonym. If I'm looking for one, I should be able to find the other, and vice versa. Or you might speak a language that likes to mash words together until they become big, impressive, compound word. So you need to decompound them, because some people will search for them as they are. Some people will put a space in there. And again, that's something that you have to account for. And that kind of gives you, together with everything else that we've talked about, the idea behind the analysis process. It's kind of to normalize it and to allow for whatever the combination of the text in the book and the text in the query, you need to make them the same. It doesn't have to have anything to do with the source words. For example, one other popular analyzer is a phonetic analyzer, where it just translates this into metaphones and different kind of symbols of how we pronounce it. Super useful if you're building a search system for a call center, because nobody knows how to spell different names, but hopefully they will pronounce it the same. So that's kind of how you build it. Now, what do you get for it? Why is it do not scan? So first is the relevancy. We don't really care about what are all the different documents that match. We more care about how well do they match. Typically, when I'm doing full text search, I'm interested in the top 10, top 100, top and whatever. So that's one part. In our simple example, we could switch from using sets to using something like a counter to get a first kind of naive way how to capture relevancy, so that we would calculate not only that a page contains a word, but how many times does it contain the word. So that would immediately kind of help us there. One super important part when you think about it, how it works. If I gave you a very thick book that has not only one index, but 2, one for locations and one for names, and I would ask you to find me a page where Honza and Ostrava appears on the same page, you would do it quite naturally. You would locate your set of pages for Honza, set of pages for Ostrava, and you would just see which one is in there. It doesn't matter that they came from different indices. That's why we don't have 10-minute long talks about what happens when your full text engine doesn't use index. Not a thing. It always has to use an index, and it can use multiple. That's why it scales also with the list of words in your vocabulary. It doesn't scale with the number of documents. But think about it, like the index at the end of the book, it only cares about the size of your vocabulary, the size of the dictionary. So, to summarize it in 4 words, It's you do the analysis to normalize everything, and then that's where all the magic is. The rest is just very easy lookup into, you can visualize it clearly as a dictionary with a set, and all of your assumptions that you have based on this extra super simplified model will hold even for a larger production systems. So that's it. That was a speed run of how full text search works. Thank you very much for your attention.
Thank you, Hansa. And now I would like the organizers to show me what community announcements are. So what are we doing here? 1 second. All right. So we will have some community announcements, which are getting set up. Dealing with technical issues. All right. No technical issues remain. Just plugging things in. All right. Everything's on the laptop. All right, this laptop is on the edge. Right, we do need some mirroring to happen. Right pixels to go down the line again. Yeah, this is... It went surprisingly smoothly this time. I remember Lightning Talks always being about the long waits between talks, and the yeah, the competitions between Linux and Mac and how fast they are to connect to HDMI. Is this it? Are you ready? All right, go ahead.
I have with myself here on the stage. And we are both from Warsaw, and we just wanted to brag about it, and also invite you for the Warsaw Python Pizza. Are you asking? Okay.
Hello.
I think it's working. Probably,
You need to hold it
we
closer.
need to speak louder. So yeah, Warsaw. Okay, maybe it's the person issue. Okay, so Warsaw Python Pizza gonna happen probably on 9th of May 2026, and we want to invite all of you. We are the people who just came here to copy, see how it was done here. We will rebuild the whole setup and in Warsaw, and yeah, we're gonna just try to copycat what would happen here, and yeah.
And it was done really awesome here.
We have to say, yeah. So big applause for the organizers. You can actually scan this QR code, and it will probably bring you to the warsaw.python.pizza. Here is something how we just wasted a lot of energy to generate some image, which will be on the next slide. And we are also planning, it just came out today, this idea to organize a barbecue party just day before on the Pole Mokotowskie. It's like the green lungs of Warsaw. And here you can see how it will look like. You can just do a screenshot with your eyes or phones, and there are many details you will find. Actually, there is my dog and Dorota's dog, and they are competing for the Python. And that's all. See you in Warsaw, 9th of May.
See you.
Does it work? Okay. Hi everyone. I have a question. Who knows what EuroPython is? Okay, perfect. So I don't need to explain almost anything. So the EuroPython is a 7-day long conference. It's been traveling all over Europe for 25 years. It's been for the last 3 years in Prague, and this year it moves to Krakow. And it's going to be in July 13th to 19th. The CFP is already closed. We got the record number of 635 proposals. If you've been to the EuroPython before, you can take part in the community voting that started yesterday, or yeah, I think like that. So please go to the EuroPython website to see the voting page. If you don't know what EuroPython is, please go visit the website as well. And see you all in Krakow in July. And also, if you're there, there's going to be another event called EuroSciPy. Who knows what EuroSciPy is? Okay, some people know it's basically like EuroPython, but for scientific Python and for scientific community. As you can see, it says July 18th to the 23rd, and this is July 13th to 19th, so there is some overlap. The sprints between those two events will be joined, and if you start on July 13th, you can stay all the way to the July 23rd in Krakow for 11 days of awesomeness. And if you're also in Krakow on other dates, we have a community in Krakow called PyConic, which we organize meetups. The closest one is on the 5th of March. How many of you are from Krakow? Okay, that's about the third of the people, I guess. So if you are based in Ostrava or somewhere else, it's very easy to get to Krakow. From Ostrava specifically, there are direct trains, and on a highway it takes like 2 hours to get to the city. So we highly recommend visiting the meetup on one of those days. And for the meetups that are closer, I'm going to give it back to Lumir.
Thank you. Yeah, hello once again, everybody. And if you really like the nice people all around the Python community and you really hate trains, you don't have to use them because we have Python meetups all around. Here one in Ostrava and also around the Czech Republic, happening basically everywhere. If you want, join us. It's open for everybody. We also, accept talk. It might be longer or shorter as this event was. And if you want to organize your own, feel free to contact us as well, and we will tell you how. I'm doing it for more than 10 years now, so I have a little bit of experience with that. Thank you.
And I hope the next one's mine. Yes. So, after many years of hosting our friends from EuroPython, there's one kid that's making a comeback, which I will introduce with a short video to give you a hint. If you know what's happening this year again. Yes, PyCon CZ is back. It will be in Pilsen, and for the first time ever, I'm announcing the exact date, which will be 25th to 27th September. It's a weekend. And 28th is a public holiday, so we are planning a big after party. Here you can scan a QR code. This is how you make people scan a QR code. And we are right now in the call for sponsors stage. So if you know a company that has a lot of money that they don't use, I have a just cost for the money to use them. Thank you all, and yeah, next one.
Yeah, okay, so hopefully it's mine, but okay. So I would just like to invite you, if you are from Prague, which probably is not so likely, but if you're on a direct train to Prague or live close, we are holding a series of meetups called PyData Prague. And the next one, and it's probably the first place where it is semi-officially announced, is that the next one will be held on the 10th of March this year. We typically have two talks plus a lot of plus some refreshments. And if you want to attend and see some details, please visit pydata.cz, where you can go to the meetup page where you can register, etc., etc. Thank you.
There's one more slide. Whose slide is this?
Hello. I think I'm in the frame. Yes. So this October 12-13 is the second session of PyCon Greece. We haven't. We don't have yet the tickets or the CFP open, but it will be, I think, inside the March. So yeah, just save the date. Thank you.
Okay, and last but not least, if you are from Ostrava, there are many other issues organized by Tech Meetup. You can currently check their LinkedIn, where they have a voting about issues that you would like to see at their events. Yeah, so they also helped us to promote this event, so many thanks to them. And I think you can close it now. Okay, and I can go directly to the closing session. I would like to thanks a lot to all speakers who came here, to every one of you who paid attention to them. Many thanks to Petr Victorin, who I forgot to introduce at the very beginning. And who was guided you through all the day. Also thanks to sponsors, Red Hat, Berkeley's, Pivots, and the EuroPython Society. Also many thanks to Impact Hub. I hope you enjoyed the day, and we will see at some other kind of conference. And now we did not book any kind of pub, but you are very welcome maybe to go and have some beer. There are several pubs around, so you are very welcome to do this social activity. And is there something else we would like to say? Yeah, you come and take stickers. Also, there's still a lot of food upstairs. You are very welcome to take it. You are also welcome to take pizza at home, like all the so? Yeah, if you see a box with pizza, just take it and run away. Nobody will judge you. Okay, so thank you very much. Hopefully see you ever again. And bye-bye. Actually, one more thing. We can stay here by 6 p.m. So it is still possible to do some networking here by the amazing food and good drinks. Okay, bye-bye.